Hello there, and welcome to the Cosmographer. Not one scenario on this list has been ruled out by physics. That is not a figure of speech, it is the entry requirement. Number 8 is an argument published in 1958, in 2 pages, concluding that a sufficiently advanced civilization would have a moral duty to end all life painlessly, and the mechanism it would need is one the measured mass of the Higgs boson says the universe might already permit. Further down is the wiring diagram of a human brain, which at full resolution would come to about 1 billion terabytes. Below that is a list of 1,715 stars that have been in a position to watch Earth cross the face of the Sun. The entry at the top is first for a reason that has nothing to do with how likely it is. 10 scenarios, counted down from 10 to 1, ranked by how late the warning would arrive. Get comfortable and settle in. If a long, careful walk through what physics has not ruled out sounds like a good night to you, a quiet like and subscribe helps this channel reach more curious minds like you. Because by the end of this list, the most unsettling entry on it will not be the one that could do the most damage. It will be the one nothing could ever check. Let's begin at number 10. Number 10, the Silent Watchers. This is a list of 10 scenarios about what an alien civilization might be, and what contact with one might actually mean. Not one of them is a report of something that is happening. Every one of them is a description of something that physics has not ruled out, and that is a much more interesting category than it sounds. Each entry is built the same way. The real science comes first, a published paper, a measured number, an instrument that was actually pointed at the sky. Then comes the scenario that the science permits, clearly marked as a scenario. Where the popular version of a story is wrong, this list will say so, and in almost every case, the correction turns out to be more interesting than the myth it replaces. Before we begin the descent, it is worth setting the scale of the thing we are talking about. The observable universe is about 93 billion light-years across. It contains something on the order of 2 trillion galaxies. Our own galaxy, one of those 2 trillion, holds somewhere between 100 billion and 400 billion stars, depending on how you count the faintest ones. Work by the Kepler Space Telescope gave us a number that transformed this question from philosophy into arithmetic. Roughly 1 in 5 stars similar to the Sun appears to host a roughly Earth-sized planet in the temperate zone, the band where liquid water is possible. Extend that across our galaxy, and you get something on the order of 10 billion candidate worlds. 10 billion in one galaxy out of 2 trillion galaxies. Against that number, here is the complete and current inventory of confirmed detections of anything alive anywhere other than Earth. 0. Not a disputed detection, not a contested one. 0. That gap is the reason this list exists. And this list has a specific organizing principle, which is worth stating plainly before we start, because every entry from here to the end is ranked by it. These 10 scenarios are not ranked by how likely they are. They are ranked by a single question: how late does the warning arrive? How much of this scenario could already be true right now, at this moment, without producing a single thing we could detect? Number 10 is the scenario we could still, in principle, catch in the act. It makes predictions. Instruments have been pointed at those predictions, and they have returned real results. As the list descends, the window for noticing gets narrower. By the middle of the list, the notice arrives after the event. By the bottom, noticing is the thing that gets erased. The entry at the top is first for a reason that has nothing to do with probability. It is, in fact, the least likely thing on this list. We will get there. Let us start with the oldest version of the question, and with a lunch. It was the summer of 1950, at Fuller Lodge in Los Alamos, New Mexico. Enrico Fermi walked over to lunch with three colleagues, Emil Konopinski, Edward Teller, and Herbert York. On the walk, they were talking about flying saucers, which were very much in the air that year. A cartoon by Alan Dunn had run in the New Yorker on the 20th of May, blaming the disappearance of New York City's trash cans on aliens. Konopinski remembered the cartoon as fresh, which is how, decades later, the date of the lunch was finally pinned down. The conversation drifted, as physicists' conversations do, into probabilities. Teller recorded Fermi, asking how likely it was that within the next 10 years there would be clear evidence of a material object moving faster than light. Teller answered 1 in a million. Fermi said that was much too low. The probability, he said, was more like 10%. Teller called that the well-known figure for a Fermi miracle. Then they sat down. And apropos of nothing at all, Fermi asked the question. The three men who were there remember it 3 different ways. Konopinski recalled it as, "But where is everybody?" York recalled it as, "Don't you ever wonder where everybody is?" Teller recalled it simply as, "Where is everybody?" York added a line worth keeping. Somehow we all knew he meant extraterrestrials. Here is the first correction of this list, and it is a small one, but it sets the tone. The version you have almost certainly heard is that Fermi listened to someone lay out the numbers for alien civilizations and then said, "Well, if they exist, then where is everybody?" That is not what happened, and Teller said so directly. Fermi did not tie the question to any conversation that was going on. It arrived out of nowhere, and it got a laugh. The reason we know any of this at all is a piece of ordinary scholarly diligence. A physicist at Los Alamos named Eric Jones realized in the early 1980s that the most famous question in the field had no source. So he wrote to the 3 surviving witnesses, collected their letters, and published the whole thing as a Los Alamos report in March of 1985. Konopinski's letter, dated the 1st of February that year, contains the line, "I am now certain that it took place in the summer of 1950. Before that report existed, the story circulated only because Carl Sagan had repeated it in a book in 1966, and Sagan could not remember where he had heard it. 11 years after the lunch, in November of 1961, 10 people met at the National Radio Astronomy Observatory at Green Bank in West Virginia to see whether the question could be turned into a calculation. They were an unusual group. Peter Pearman organized it. Frank Drake was already there at the observatory. Melvin Calvin won the Nobel Prize in Chemistry that same year. John Lilly worked on dolphins, and the group named itself the Order of the Dolphin after his subject. Bernard Oliver ran research at Hewlett-Packard. Carl Sagan was 27. Otto Struve was the observatory's first director. Over 2 days, they built the equation that carries Drake's name. It multiplies together the rate at which stars form, the fraction with planets, the number of habitable planets per system, the fraction where life begins, the fraction where it becomes intelligent, the fraction that becomes detectable, and how long detectability lasts. Their estimates put the number of communicating civilizations in this galaxy somewhere between 20 and 50 million. Drake's own summary was blunter. The number is roughly equal to how long a civilization stays detectable. Now, 65 years on, here is the honest state of that equation, and it is the load-bearing fact of this entire subject. 3 of the 7 terms are now measured tolerably well. Stars form in this galaxy at a rate of roughly 1 to 3 a year. The fraction of stars with planets may be close to 1, very nearly all of them. The number of temperate planets per system is constrained by Kepler. The other 4 terms have never been measured. Not imprecisely measured. Not measured. The fraction of habitable worlds where life begins, the fraction where it becomes intelligent, the fraction that becomes detectable, and how long detectability lasts, no instrument has ever touched any of them, because the sample size for all 4 is 1. The equation's output range is set almost entirely by numbers nobody has. Drake had already run the search. Project Ozma used the 85-foot Howard Taytel telescope at Green Bank from April to July of 1960, about 150 hours of observing. 2 targets, Tau Ceti, about 12 light-years away, and Epsilon Eridani, about 10.5. The frequency was 1420 MHz. The result was nothing. The one signal that got everybody's pulse up was traced to a high-flying aircraft. Which brings us to the scenario itself, and to a paper 3 pages long. In July of 1973, in the journal Icarus, a radio astronomer named John Ball published a paper titled, simply, The Zoo Hypothesis. His abstract reads, in full, extraterrestrial intelligent life may be almost ubiquitous. The apparent failure of such life to interact with us may be understood in terms of the hypothesis that they have set us aside as part of a wilderness area or zoo. That is the whole idea. The silence is not an absence. It is a policy. A correction, since Ball is routinely described as an MIT scientist. In 1973, he was a radio astronomer at Harvard College Observatory and at the Harvard-Smithsonian Center for Astrophysics. He did not join MIT's Haystack Observatory until 1984, 11 years after the paper. He worked there until he retired in 2006, and he died on the 6th of August, 2019, aged 83. Ball himself put his finger on the problem with his own idea, and it is the reason this scenario sits at number 10 rather than lower down. A policy of non-interference, if it were properly executed, would be undetectable in principle. There is no observation that would confirm it, and no observation that would refute it. It is a hypothesis that seals itself. Hold that phrase. We will need it again at the very bottom of this list. Now, if the watchers are real, what is the best physical evidence anyone has ever had? There is exactly one candidate, and it lasted 72 seconds. On the 15th of August 1977, at about 11 at night, a radio telescope in Ohio recorded something it had never recorded before and never recorded again. The telescope was called Big Ear. It belonged to Ohio State University and sat on the grounds of Perkins Observatory in Delaware, Ohio. It was not a dish. It was a flat reflector, roughly 103 meters by 33, feeding a curved one, a design that could not track anything. You adjusted it in altitude, and then you let the Earth's rotation drag its beam across the sky. The signal was not noticed that night. It was found days later by Jerry Eman, at that point a volunteer, working through fan-fold line printer output. Picture the room. Continuous paper, folded into a stack, printed in a fixed-width font. Column after column of 2 character intensity values, and almost all of them blank, or 1, or 2, the numeric texture of an empty sky. Page after page of nothing, which is what this work is, almost always. And then a column that climbs. 6. Then E. Then Q. Then U. Eman picked up a red pen, circled the 6 characters, and wrote one word in the margin. Wow. He did not yet know what he had. He did not know that the rise and fall of those 6 values matched the telescope's transit profile precisely. He did not know that it had appeared in only one of the 2 feed horns. And he did not know that he would point that instrument back at that patch of sky roughly 50 times over the following years and see nothing at all. Let us take the signal apart, because the detail is the payoff here. Start with the duration. Big Ear could not track, so any fixed point in the sky stayed inside its beam for exactly 72 seconds as the Earth turned. The signal rose and fell in a clean, symmetric curve, matching that 72-second transit exactly. That is the single strongest argument that it came from the sky rather than from something on the ground. Interference from a nearby source does not politely imitate the rotation of the Earth. Now the 6 characters. The sequence was 6, E, Q, U, J, 5, and it is not a code. It is an intensity chart drawn in characters because printers of that era did not draw graphs. Each character represents the signal strength above the rolling background, measured in standard deviations, over a 12-second window, 10 seconds of integration, plus 2 of processing. 6 characters at 12 seconds each is 72 seconds. Blank means less than 1 standard deviation. The digits are literal. Then the letters continue the count. A is 10, B is 11, and so on up to Z, which is 35. So read it again. 6 standard deviations. 14. 26. 30. And that U is the peak, and it is the highest single character recorded in 22 years of that survey. Then 19. Then 5. The frequency was about 1420.45 MHz, sitting roughly 50 kHz above the rest frequency of neutral hydrogen. The receiver had 50 channels, each 10 kHz wide. The signal was confined to essentially one of them. And now the detail that almost every telling of this story leaves out, and which matters more than any of the above. Big Ear had 2 feed horns. A genuine source in the sky should have swept through both, producing 2 detections about 3 minutes apart. The wow signal appeared in only one. Worse, the way the data were processed makes it impossible to determine which horn it was, which leaves 2 candidate positions on the sky, about 3 minutes of right ascension apart. The declination is pinned down, -27 degrees, in the constellation Sagittarius, just northwest of the globular cluster known as M55. And it was never repeated. That sentence is doing a lot of work, and it deserves the full accounting. Eamon researched the position with Big Ear roughly 50 times. Robert Gray bought a 12-foot telecommunications dish in 1980 and ran his own scans of that patch of sky, regularly, from 1983, for about 15 years. He led searches on the Harvard Array at Oak Ridge in 1987, and again in 1989. He and Kevin Marvel used the Very Large Array in September of 1995 and May of 1996. He and Simon Ellingson ran 6 14-hour sessions on a 26-meter dish in Tasmania in 2002. Breakthrough Listen pointed the Green Bank Telescope and the Allen Telescope Array at it in May of 2022. Every single one of those returned nothing. There is something worth sitting with in that list, and it is not the signal. 2 men, and 1 patch of sky, and 45 years. Jerry Amon found it as a volunteer and spent the rest of his working life trying to see it again. Robert Gray bought a dish, taught himself the work, talked his way onto some of the finest instruments on the planet, and kept at it for 4 decades. He died in 2021 without ever getting a second detection. Neither man ever claimed more than he had. In a subject that rewards overstatement, both of them simply reported that they had looked and that there was nothing there. Two explanations have been offered since, and both deserve fair treatment. In 2017, Antonio Paris proposed that hydrogen surrounding two comets had produced the signal. It fails on 4 independent counts. The comets were not in the beam at the right time. Comets are not known to emit strongly at that frequency. A cometary coma is far wider than the telescope's beam, which means it would necessarily have appeared in both horns, so it structurally cannot produce a one-horn detection. And a diffuse cloud cannot produce a 30 standard deviation spike confined to a single 10 kHz channel with a clean transit profile. In 2024, a team at the University of Puerto Rico at Arecibo, led by Abel Mendez, took a more careful run at it. They used archival Arecibo drift scans from early 2020 that deliberately imitated Big Ear's method at higher sensitivity, and they found narrowband signals near the hydrogen line at several positions, 2 orders of magnitude weaker and all traceable to small, cold clouds of neutral hydrogen. Their proposal is that the WOW signal was a sudden brightening of the 21-centimeter line in one such cloud, stimulated by a passing burst of energy from a magnetar. That is a serious piece of work, and it may well be right. It should be labeled accurately. As of now, it remains an unpublished preprint, submitted to a journal and not yet accepted. And on its own terms, it does not obviously solve the two-horn problem. One more piece of context on why 1420 MHz was the frequency everybody was watching in the first place. In September of 1959, Giuseppe Cocconi and Philip Morrison published a short paper in Nature pointing out that neutral hydrogen emits at 21 centimeters, that hydrogen is the most abundant element in the universe, and that therefore any radio-capable species anywhere would already know that frequency. It is a meeting place that requires no prior agreement. Everybody arrives already knowing the address. Now we come to the piece of evidence this scenario is most often built on, and it is the one place where this list has to do some demolition. The Black Knight satellite is usually described as an object of unknown origin in polar orbit, watching us, possibly for 13,000 years. It is not one story. It is 6 unrelated real events, welded together long after the fact, and every one of the 6 is more interesting on its own. The first is Tesla, in 1899 at Colorado Springs. He reported rhythmic, repeating signals he could not attribute to any terrestrial source, and published the account in Collier's Weekly in February of 1901, describing a regular repetition of numbers. He believed they came from Mars. Candidate explanations since include interception of Marconi's transmissions and the moon Io passing through Jupiter's magnetic field. What matters here is what Tesla did not say. He never described an object, a satellite, or anything in orbit. The second is a genuine and still partly unsolved radio phenomenon. In 1927, Jürgen Hals in Oslo reported hearing echoes of Dutch shortwave transmissions returning seconds after the original. Carl Sturmer published it in Nature in 1928, and Balthasar van der Pol published in the same volume. Controlled transmissions began in March of 1928, and on the 11th of October that year, van der Pol telegraphed a series of delays between 3 and 15 seconds, more than half of them over 8. Roughly 15 distinct explanations have been proposed. They remain incompletely understood. But they are an atmospheric propagation problem, and the crucial point is this: they are echoes of our own transmissions. Nothing up there was transmitting. The third is a newspaper story. In May of 1954, Aviation Week reported that the Air Force had detected artificial satellites in orbit. This was 3 years before Sputnik, so it was a considerable claim. It came from Donald Keyhoe, a retired Marine major who by 1954 was a full-time flying saucer author with no government position of any kind. The Air Force denied it flatly, saying it was not watching any satellites, artificial or otherwise. The fourth is a real object. In February of 1960, American tracking picked up an unidentified dark object in polar orbit, and the press speculated about a Soviet spy satellite. Within weeks, the Secretary of the Air Force identified it as hardware from Discoverer 8, launched the previous November, half of a casing shroud whose twin had already been accounted for. The fifth is an honest mistake, honestly retracted. In 1973, the Scottish writer Duncan Lunan argued in the British Interplanetary Society's magazine that the delays in those 1920s echoes encoded a star map from a probe originating at Epsilon Bootis. He later withdrew the interpretation himself after finding errors in his own stellar positions. And the sixth is the photographs, which are the only part most people have actually seen. In December of 1998, the Space Shuttle Endeavour flew mission STS-88, the first shuttle assembly flight for the International Space Station, mating the Unity module to the Russian module Zarya. There were 3 spacewalks, all performed by Jerry Ross and James Newman. On the third one, on the 12th of December, the crew was installing thermal covers over trunnion pins, and one of those covers, an insulation blanket, came loose from its tether and drifted away. The loss was captured live on the air-to-ground loop. Commander Robert Cabana can be heard saying, "Jerry, one of the thermal covers got away from you." Sergei Krikalev photographed it as it went. Those photographs are the Black Knight. James Oberg, a former NASA flight controller who knows Ross personally and knows Krikalev, wrote the standard analysis of them. His point is a practical one about human perception. In microgravity, a floppy blanket tumbles in a way nothing on Earth tumbles, and in unfiltered sunlight against black sky, it reads as a rigid, three-dimensional, metallic object. For people only familiar with Earth-bound behavior, he wrote, the motion of objects in space can look strange. Now, here is the thing to notice. The zoo hypothesis does not need the Black Knight. It is untouched by the Black Knight being a thermal blanket. Ball's argument never rested on anyone finding an artifact and learning that a famous photograph shows insulation does not weaken it by 1%. That is precisely the problem with it. Nothing that could be found in Earth orbit and nothing that could fail to be found would move this hypothesis in either direction. Which is not to say nobody is looking properly. Artifact searching is a real research program now. The Vasco project, led by Beatriz Villarroel, searches digitized photographic plates from Palomar, taken between 1949 and 1957, looking for star-like points that appear on one plate and are absent from every survey since. Their headline case is a red sensitive plate from the 12th of April, 1950, with a 50-minute exposure, showing 9 star-like points, inside a box 10 arc minutes on a side, absent from the blue plate taken 30 minutes earlier, absent from a plate taken 6 days later, absent from everything modern. That result is contested, and honesty requires saying how. A re-examination found the 9 sources had narrower and rounder profiles than genuine stars, and attributed them to flaws in the photographic emulsion. Villarroel's team replied that a flash lasting under a second should look sharper than a star smeared across a 50-minute exposure. And the original paper itself conceded that contamination of the plates cannot be excluded, and that the team did not have the original glass to inspect. This is live and unresolved. The sober version of the search comes from James Benford, who published a paper in 2019 making the case that if anyone ever left a probe in this system, the sensible place for it is co-orbital space, objects sharing Earth's orbital period, which come closer at approach than anything except the Moon, and which offer permanent sunlight and a stable anchor. His prime target is a small quasi-satellite called 2016 HO3. He proposed simply interrogating it with planetary radar. Nobody has. If the silence is a policy rather than an absence, then everything our species has ever done has been happening in front of an audience that has so far chosen not to say anything. Every war, every treaty, every launch, watched with the patience of a field study. But a civilization that only watches is the least demanding thing on this list. The next entry needs nothing from us except the atoms we are standing on. Number 9. The Resource Harvesters. On the 3rd of June 1960, the journal Science published a letter 2 pages long. Its author was Freeman Dyson, and its title was Search for Artificial Stellar Sources of Infrared Radiation. An entire genre of science fiction rests on those 2 pages, and almost everyone who invokes them has the idea backwards. Here is what Dyson actually wrote. The byproduct of an advanced civilization's energy use, he said, is likely to be the large-scale conversion of starlight into far infrared radiation. The thing to look for is a dark object, having a size comparable with the Earth's orbit, and a surface temperature of 200 to 300 Kelvin. It would radiate, in his words, as copiously as the star which is hidden inside it, but the radiation would be in the far infrared. Read that again and notice what it is. It is not a proposal for a structure. It is a proposal for a search. Dyson's insight was thermodynamic, not architectural. If you gather starlight and put it to work, the work eventually turns into heat, and the heat has to go somewhere. It leaves as long wavelength infrared, and it leaves whether you want it to or not. You can hide a machine. You cannot hide the temperature of the machine. That is the sentence worth carrying through the rest of this list. The waste heat is the part you cannot hide. 2 corrections, because they matter. Dyson never wrote the phrase Dyson sphere. And in the letters column that followed his paper, he explicitly rejected the version everyone now imagines. A solid shell or ring surrounding a star, he wrote, is mechanically impossible. The form of biosphere which I envisaged consists of a loose collection or swarm of objects traveling on independent orbits around the star. He used the word biosphere in its ecological sense, and he credited the idea to Olaf Stapledon's 1937 novel Star Maker, in which many a star without natural planets came to be surrounded by concentric rings of artificial worlds. His objection to the solid shell was not aesthetic either. A rigid sphere centered on a star feels no net gravitational pull toward it. The attraction from every part of the shell cancels out, which means the star is not held in the middle of anything. Nudge the 2 apart, and nothing pulls them back. The shell drifts until one side of it touches the star it was built to enclose. The swarm has no such problem, because every piece of it is simply in orbit, doing what orbits do. The mass budget is the part that makes it feel real. Take 1 Jupiter's worth of material and spread it over a shell at the distance of Earth's orbit, and you get a layer 2 or 3 meters thick. That is the whole engineering problem, stated in one line. Dismantle 1 large planet, and you can intercept a star. So the search has been run. And once, for about 2 years, it looked as though it had found something. The star is catalogued as KIC 8462852, and it is usually called Tabby's star, after the astronomer who led the paper. Start with a correction, because a wrong date circulates constantly. The dimming was not discovered in 2004. The star was catalogued long before that, but the anomaly came out of data from the Kepler Space Telescope, which stared at more than 100,000 stars in the constellations Cygnus and Lyra from 2009 to 2013, measuring the brightness of each one every 30 minutes. And it was not found by a professional. Kepler's light curves were put in front of the public through a project called Planet Hunters, which showed volunteers 30-day segments and asked them to flag anything unusual. Volunteers flagged this one on the discussion board using words like bizarre and interesting and giant transit. Several of them are named authors on the resulting paper, which was published under Tabitha Boyajian's name in the monthly notices of the Royal Astronomical Society in April of 2016, and which carried the subtitle, "Where's the Flux?" The star itself is unremarkable. An F-type main sequence star, about 1,470 light-years away, roughly 1 7/10 the radius of the Sun, with a small companion star about 885 times the Earth-Sun distance away from it. What it does is not unremarkable at all. From the paper's own table, the dips in brightness run 0.5%, then 16%, then 0.3%, then 21%, then 3%. In calendar terms, the two large ones fall around March of 2011 and late February of 2013, roughly 2 years apart. To feel what 16 and 21% mean, take the largest planet in our own system. Jupiter, crossing the face of the Sun as seen from outside, blocks about 1% of its light. This star was losing 1/5 of its light. Nothing in the standard catalogue of stellar behavior does that. The timing did not help. That same January, a group at Penn State led by Jason Wright had published a paper on precisely what a transiting megastructure would look like in a light curve. A blog post of Wright's in October of 2015 and an article in The Atlantic shortly after turned an obscure light curve into a global story. Then came a claim that made it stranger. Bradley Schaefer reported that the star had faded by 0.165 magnitudes per century between 1890 and 1989, using Harvard's archive of photographic plates. A century of steady dimming is not something dust does casually. That claim did not survive, and how it died is worth knowing. Two independent groups showed the trend was an artifact of a known systematic in the plate archive, a stretch of years in the middle of the 20th century where the calibration shifts. Split the data at 1970, and both halves are flat. A separate study of a German plate archive found the star's brightness constant from 1895 to 1995 within a few percent. The century of dimming was a property of the archive, not of the star, which left the dips. And here the resolution is genuinely beautiful physics. Boyajian ran a crowdfunding campaign, raised over $100,000 from more than 1,700 people, and bought roughly a year of monitoring on a global network of telescopes. Combined with observations from orbiting instruments, the result was this: the star dims more in blue light than in infrared. That single fact settles it. A solid object is achromatic. It blocks every wavelength equally because it is opaque. A brick does not filter. This occulter filters. Therefore, whatever is passing in front of the star is made of particles comparable in size to the wavelength of light itself, no more than a few microns across. It is dust, not a structure. Fine, uneven, circumstellar dust, most plausibly debris from a body that was disrupted or is evaporating, and one line of work reads the pattern as a train of transiting comets on a period of about 928 days. The specific source is still unsettled. The megastructure is not. Every SETI search of that star radio arrays, optical flash searches, the largest steerable dish on the planet, returned nothing. The most recent version of the search is more systematic, and its ending is faster. In May of 2024, a team at Uppsala University published the second paper of a project called Hephaistos. They combined optical and infrared catalogues covering 5 million objects, looking for stars with an infrared excess that no ordinary process explains, and used a neural network to filter cases where the infrared might be coming from a neighbor rather than the star. 5 million objects. 7 candidates. All of them small red dwarfs, all within about 1,000 light-years, all with infrared excess for which, in the paper's careful phrasing, astrophysical phenomena cannot easily account. 17 days later, a separate team cross-matched all 7 against 4 radio surveys. 3 of the 7 had radio sources sitting within a few arcseconds of the star's position. One of those had a spectral index of -0.52, which is the fingerprint of synchrotron emission from the jets of an active galaxy. Their conclusion, in their own words, all 7 candidates have very likely been misidentified. The probable reality is a class of object called hot dust-obscured galaxies, extremely distant, extremely dusty galaxies, faint in the near-infrared and bright further out, sitting behind the star and bleeding into the same measurement. The infrared survey's beam is 6 to 12 arcseconds wide, which is more than enough room for a background galaxy to hide in, and these objects appear roughly once per 31 square degrees of sky. That is plenty to explain 7 contaminants in a sample of 5 million. It should be said accurately, this has not been formally resolved, and nothing has been retracted. Follow-up with a larger telescope is planned and has not happened. The honest summary is that 7 candidates were flagged, and within 3 weeks, another group showed that all 7 are most likely galaxies bleeding into the beam. So the searches keep coming back empty. Which brings us to the version of this scenario that does not require anyone to be flying anywhere. In 1949, in a series of lectures at the University of Illinois, John von Neumann worked out how a machine could build a copy of itself. His design has 3 parts: a description, a universal constructor that reads the description and builds what it specifies, and a universal copier that duplicates the description. The crucial move is that the description gets used twice, once as instructions and once as an object to be copied. He worked this out before anyone knew the structure of DNA. He described in the abstract exactly the trick that life uses. The mathematical setting came from his colleague Stanisław Ulam, who suggested modeling the whole thing on a grid of cells that update according to fixed rules, the origin of what are now called cellular automata. 11 years later, in Nature, Ronald Bracewell suggested a use for it. Instead of broadcasting across interstellar distances, park a machine in the target system and let it wait. Freitas later made the security argument explicit, and it is a good one. A beacon is heard by everyone and tells all of them where you live. A probe listens, reports back on a narrow beam, and gives away nothing. Bracewell's probes were messengers, not self-replicators. The marriage of the 2 ideas came 20 years after that. There is even a calculation for when each approach wins. Freitas and Francisco Valdez worked out the crossover. For programs lasting more than about 10,000 years, covering more than 1 million stars, self-replicating probes are cheaper. For a survey of 1,000 stars inside 100 light-years, simple one-shot probes win. Which means the strategy a civilization chooses tells you how ambitious it was and how long it expected to last. In 1980, Robert Freitas designed the machine. His probe arrives in a target system, selects a rocky moon orbiting a Jupiter-like planet, and lands. Then, over 500 years, It constructs a factory complex. Thereafter, the factory produces one exact copy of the original probe every 500 years. He assumed a cruising speed of 1/10 the speed of light, taken from a British study of interstellar propulsion, and a 10-fold improvement over the manufacturing technology of his day. Consider what that actually looks like, because the design is a place, not a diagram. A rocky moon, orbiting a gas giant, in a system that has no name because nothing has ever named it. The probe comes down on a plain of frozen rubble and does not move again. For 5 centuries, nothing happens that anyone would call an event. A factory grows the way a reef grows, one deposited layer at a time, slowly, drawing metals out of the regolith and power from a star that has no idea it is being used. There is no consciousness in it. There is no decision. Nothing anywhere in the process wants anything. At the end of 500 years, the factory opens and releases one machine, identical to the one that landed. That machine leaves for the next system. And the factory, without pausing, begins building the next one. The arithmetic that follows is the whole scenario, and it is the reason this idea has never gone away. Published estimates for how long a self-replicating probe needs to reach every star in the galaxy run from about 650,000 years, assuming a 1/10 of light speed and no delays, through a few million years once you allow realistic construction time, up to Frank Tipler's deliberately conservative figure of 300 million years. Take the largest of those. 300 million years is about 2% of the age of this galaxy. Whatever the true number, it is a rounding error against 13 billion. Tipler drew the obvious conclusion and put it in his title: extraterrestrial intelligent beings do not exist. If they existed, he argued, their machines would have arrived here a very long time ago, and the fact that we are standing on unclaimed real estate is the evidence. 2 answers to that have held up, and both are more interesting than the argument they answer. The first came from Geoffrey Landis in 1998, and it is a piece of statistical physics rather than speculation. Colonization is not a smooth, expanding wave. It is a percolation problem, the same mathematics as fluid seeping through porous rock. If the probability that any given colony goes on to launch further colonies falls below a critical value, expansion does not fill space. It forms finite clusters with permanently uncolonized voids between them. An inhabited galaxy can leave this solar system untouched forever, without any policy, any conspiracy, or anyone deciding anything. Just statistics. The second came earlier, from Carl Sagan and William Newman in 1981, and it is the harder blow. They modeled colonization as a diffusion process with realistic population dynamics, and calculated how long a civilization would need to survive for a colonization wave to reach Earth from the nearest independently arisen neighbor. Under one model, the answer was 2.6 million years. Under another, 20 million. Under a third, 13 billion years, longer than the universe has existed. Their conclusion was 4 words. There is no galactic empire. Their analogy was better than their equations. You can walk across Rome in a day. Rome was not built in a day. What makes this scenario unsettling is not that anyone hates us. Nothing in it requires anyone to have decided anything about this planet at all. A construction crew clearing ground does not hate the colony living under it. The machinery simply has no category for it. But a machine that takes the ground out from under you at least wants something. The next entry on this list wants nothing at all and believes it is doing you a kindness. Number 8. The merciful extinction. This entry begins with an argument that fits in 2 pages and ends with a piece of physics that fits in one sentence, and the distance between them is shorter than anyone would like. Start with the argument. In 1945, Karl Popper published The Open Society and Its Enemies, and in a footnote, he proposed replacing the standard utilitarian aim with a negative version of it. Instead of the greatest happiness for the greatest number, he wrote, we should aim for the least amount of avoidable suffering for all. And elsewhere in the same book, it adds to the clarity of ethics if we formulate our demands negatively, if we demand the elimination of suffering rather than the promotion of happiness. His reasoning is an asymmetry most people recognize the moment it is pointed out. Suffering makes a direct moral appeal for help. There is no equivalent call to increase the happiness of someone who is already doing well. A person in pain in front of you generates an obligation. A person having a pleasant afternoon does not. Popper was not proposing a system. He was making a small, careful adjustment to how ethical demands are phrased. 13 years later, in October of 1958, a philosopher named Ninian Smart published a reply in the journal Mind. It is 2 pages long, and it did 2 things. It gave the position its name, negative utilitarianism, and it identified the problem that has followed the idea ever since. If only the reduction of suffering counts, Smart pointed out, then consider a ruler who had the power to destroy the human race instantly and painlessly. Continued existence guarantees some suffering. Extinction guarantees none. On this ethics, that ruler would not merely be permitted to act. He would be obliged to. Smart's own phrase for him has stuck. Would not our benevolent world exploder, he asked, be truly the savior of mankind, and for that matter of the animals too? He anticipated the obvious escape route and closed it. Popper's companion principles about tolerance and about not permitting tyranny are principles about the long run. And in this case, Smart noted dryly, there is no long run to worry about. 2 corrections before we go on. The first is that Popper supplied the asymmetry and Smart supplied the name and the objection. Popper was not a utilitarian and never used the term. The second is about Arthur Schopenhauer, who gets invoked in this context constantly and is almost always misdated. Schopenhauer died on the 21st of September, 1860. Any philosophical work attributed to him in 1868 is not his, because he had been dead for 8 years. His actual books are The World as Will and Representation, first published in 1819 and expanded twice, and Parerga and Paralipomena in 1851. The modern version of this argument belongs to David Benatar, whose book Better Never to Have Been was published by Oxford in 2006. So here is the scenario, and it is worth stating precisely because the imprecise version is much less interesting. A civilization that adopted this ethics and had the means to act on it would not arrive as conquerors. It would arrive as physicians. It would not be angry. It would have done this before, many times, and it would regard each occasion as a completed act of care. And the unsettling feature is not that the reasoning is deranged. It is that inside its own framework the reasoning is valid, and a philosopher in London worked out exactly why, in 1958, in 2 pages, without any of this in mind. Now the physics, because this is where the entry stops being philosophy. On the 15th of May 1977, Sidney Coleman published a paper in Physical Review D called Fate of the False Vacuum. A companion paper with Curtis Callan followed in September, and the version including Gravity, written with Frank DeLucia, came in 1980. The idea in Coleman's own words is domestic, which is what makes it land. Vacuum decay, he wrote, closely parallels the nucleation processes of statistical physics, the crystallization of a supersaturated solution, or the boiling of a superheated fluid, with quantum fluctuations replacing thermodynamic ones. Once in a while, a bubble of true vacuum will form large enough that it is energetically favorable for the bubble to grow. Once this happens, the bubble spreads throughout the universe, converting false vacuum to true. The everyday version is something you can do in a kitchen. Water can be heated past its boiling point and stay liquid, provided nothing gives it a place to start boiling. It is not stable. It is waiting. Disturb it, and it converts all at once. The proposal is that the vacuum of space, the ground state of the universe, the thing everything else is built on, may be in that condition. Not the lowest energy configuration available, merely the lowest one nearby. It is worth being clear that the word false is not doing anything poetic here. In physics, the vacuum is not emptiness. It is a field configuration with a definite energy, and false simply means that this configuration is a local minimum rather than the global one. A marble resting in a dimple partway down a hillside is in a false minimum. It will sit there indefinitely, and it is not at the bottom. And this is no longer purely theoretical, which is the part that has changed recently. In 2024, a team including Ian Moss, the same theorist who worked on black holes as nucleation sites, observed false vacuum decay by bubble formation for the first time in a laboratory analog, a cloud of ultra-cold atoms behaving as a magnetic superfluid, engineered so that the mathematics governing it matches the mathematics governing the vacuum. Bubbles of the true state formed in the false one and grew exactly as the equations said they would. Nobody decayed the vacuum of space. What was demonstrated is that the process Coleman described in 1977 is not a curiosity of the algebra. It happens in systems built to obey those equations when you look. Two numbers from Coleman's paper give the scenario its shape. The first is the size. Typically, he wrote, we would expect the bubble radius to be a microphysical number, on the order of a Fermi. A Fermi is 1/1,000,000th of 1/1,000,000,000th of a meter, roughly the width of a proton. The transition that rewrites the universe begins at the scale of a single nuclear particle. The second is the speed. Once the bubble materializes, Coleman wrote, it begins to expand almost instantly with almost the velocity of light. And from those two facts follows the sentence that puts this scenario at number 8 rather than lower down. If a bubble were expanding toward us at this moment, Coleman wrote, we would have essentially no warning of its approach until its arrival. Consider why that is not a rhetorical flourish, but a geometric necessity. The bubble wall travels at essentially the speed of light. Light is also the fastest carrier of any news about the bubble. The information and the event are traveling together in the same direction at the same speed. There is no early warning system that is even theoretically possible at any level of technology in any universe with a finite speed limit. The notice and the arrival are the same moment. Picture it properly and without melodrama, because the honest version is stranger than the dramatic one. Somewhere, at a moment with no particular significance, in a volume roughly the width of a proton, the vacuum changes state. There is no flash, because there is nobody in that volume and nothing there to see. It is energetically favorable for the region to grow, so it grows, and within an interval too short to name it, is expanding at nearly the speed of light in every direction. Everything the wall passes through is not destroyed in the ordinary sense. It is not burned or crushed or scattered. It simply finds itself in a region where the constants of nature have different values, where the particles that make up atoms have different masses, where chemistry as an activity does not occur. The transition is not violent. It is a change of jurisdiction, and what is left behind is nothing at all, in a very precise sense. Coleman worked it out. All the energy released by the conversion, he wrote, goes into accelerating the bubble wall. This refutes the naive expectation that the decay of the false vacuum would leave behind it a roiling sea of mesons. In fact, the expansion of the bubble leaves behind only the true vacuum. No debris. No radiation. No sound, obviously, but also no light and no heat. A catastrophe with no duration, no witness, and no wreckage. The passage everyone quotes about this is from the 1980 paper, and it deserves to be given in full, because it is one of the few genuinely bleak paragraphs in the physics literature, and it is bleak with an odd, dry precision. The possibility that we are living in a false vacuum, Coleman and DeLucia wrote, has never been a cheering one to contemplate. Vacuum decay is the ultimate ecological catastrophe. In the new vacuum, there are new constants of nature. After vacuum decay, not only is life as we know it impossible, so is chemistry as we know it. Nonetheless, one could always draw stoic comfort from the possibility that perhaps over time, the new vacuum would sustain, if not life as we know it, at least some structures capable of knowing joy. And then the last line, this possibility has now been eliminated. So the obvious question, are we in a false vacuum? This is not idle, and it is not philosophy. It is determined by two numbers we have measured to remarkable precision. The first is the mass of the Higgs boson. The current world average is 125.20 giga-electron-volts, plus or minus 11 hundredths. The second is the mass of the top quark, the heaviest particle in the Standard Model. Measured directly from the kinematics of collisions, it is 172.57 giga-electron-volts, plus or minus 29 hundredths. Now, why those two, and why the top quark carries most of the weight? The strength of the Higgs field's interaction with itself is not a fixed number. It changes with the energy scale you probe it at, and what drives it downward as you go to higher energies is mostly the top quark's coupling. Whether that self-interaction goes negative before you reach the scale where gravity takes over, which is to say, whether a deeper vacuum exists below ours, depends far more sensitively on the top mass than on the Higgs mass. A shift of a fraction of a giga-electron-volt in the top quark moves the answer. And the answer we currently have is uncomfortable in a specific way. We are on the metastable side of the boundary, and we are very close to it. Not stable, not unstable. Sitting almost exactly on the line between the two, a coincidence physicists call near criticality, and which nobody has explained. There is no known reason why the universe should be tuned to sit within a hair's breadth of the divide between permanence and eventual decay. How long then? Here, the honest answer requires some care. One complete calculation of the vacuum's lifetime states, with 95% confidence that our universe will last more than 10 to the 58th years. Two versions of that same paper circulate with different central values, which is a good reason not to quote a single headline number. But take the conservative bound and put it against the age of the universe, which is about 14 billion years. 10 to the 58th years is at minimum 48 orders of magnitude longer than everything that has ever happened. If the universe were a single second old, the confidence bound would still be longer than any span the human mind has a word for. There is one more caveat, and it must be delivered. All of this assumes that the Standard Model holds all the way up to the scale where gravity becomes strong, with nothing new appearing in between. Where the instability sits at very high energies, gravitational corrections take over, and in the physicist's own careful phrasing, any assessment about vacuum stability becomes unreliable. So much for whether it happens on its own. Could anyone do it on purpose? The natural check came first, and it came from an unexpected direction. In April of 1983, in Nature, Piet Hot and Martin Rees asked whether a new generation of particle accelerators might trigger such an event. Their answer was that the chance is completely negligible, and the argument is elegant. The region inside our past light cone has already survived some 100,000 cosmic ray collisions at center of mass energies far beyond anything we can build. Put the scale of that in numbers you can hold. A single ultra-high energy cosmic ray hitting the top of the atmosphere delivers a collision energy in the range of 500 to 800 tera-electron volts. The Large Hadron Collider, the most powerful machine our species has built, operates at 13.6. That is a single particle from space, arriving with roughly 40 to 60 times the energy of our best accelerator, and the atmosphere absorbs them continuously and has done for 4.5 billion years. The record holder was detected on the 15th of October 1991 by a camera called Fly's Eye at Dugway Proving Ground in Utah. 320 exa electron volts in a single subatomic particle, roughly the kinetic energy of a thrown baseball, carried by something smaller than an atom. It was nicknamed the "Oh my God" particle. The telescope array, in the same state, recorded one above 240 in 2021, nicknamed Amaterasu. CERN's own safety analysis stated the conclusion plainly. Nature has already conducted the equivalent of about 100,000 collider programs on Earth alone, and the planet still exists. Extend the same reasoning across the observable universe, and the figure becomes 10 to the 31st equivalent programs, running at a rate of about 30 trillion every second. There is one mechanism in the literature that is not negligible, and honesty requires including it. In 2014, Ruth Gregory, Ian Moss, and Benjamin Withers showed that a black hole can act as a nucleation site, that an inhomogeneity in space-time dramatically increases the decay rate compared with the smooth case. The effect is real in the mathematics, and later work developed it further. And then the same result turns around and argues for our safety. If small black holes seed vacuum decay as efficiently as those calculations suggest, then a population of light black holes left over from the early universe would have destroyed the vacuum long ago. Our continued existence therefore places a limit on how many such objects exist, or on how efficient the catalysis is, or on the extrapolation itself. The mechanism that makes the scenario possible is also evidence that it has not been happening. The most useful single measurement here is not of a particle, it is of the physicists. In 2025, a survey put the question to 20 physicists at 17 institutions, 85% of whom had published work on vacuum decay. Asked for the probability that our vacuum is metastable, the mean answer was about 46%, and the distribution was strange. 6 answered exactly 50%, which is what agnosticism looks like written down. 7 answered between 70 and 95. 7 answered between 0 and 10. Then they were asked the scenario's actual question. Given that our vacuum is metastable, what is the probability that arbitrarily advanced technology could deliberately trigger decay? The mean was about 19%. But the mean hides the shape. 11 of the 20 answered 0. The most common reason given for that 0 was the same one Hutt and Rees gave in 1983. It would already have happened. The survey's own summary is the line to keep. No known natural energetic processes, they wrote, even the largest supernovae are remotely capable of this. And the authors added, explicitly, that nothing in their findings has any bearing on the safety of any existing or planned physics facility. 5 of the 20 did answer between 90 and 100%. They were asked what it would take, and their answers were particle accelerators the size of a star, accelerators operating at the scale where gravity and quantum mechanics meet, and artificial black holes. Which is a useful place to stop. The unsettling part of this entry is not that anyone would do it. It is that a species could reason its way there in good faith, in 2 pages, in 1958, and that the mechanism it would need is on the short list of things the universe might already permit. That scenario at least requires someone to arrive. The next one requires them to have left, and to have left so completely that the sky would look exactly the way it looks tonight. Number 7. The ones who left their bodies. The popular version of this scenario begins with fast radio bursts. The claim is that these flashes, arriving from across the universe, are final transmissions, the compressed contents of civilizations, broadcast outward as their senders abandoned physical existence. It is a good story, and this list is going to take it apart first, because the version left standing afterwards is better. Fast radio bursts are real, and they are extraordinary. Each one is a flash of radio energy, lasting a few thousandths of a second, releasing in that instant as much energy as the sun produces over days. The first was found in 2007 by Duncan Lorimer and his student David Narkovic in data from the Parkes telescope in Australia that had been sitting in an archive for 6 years. Nobody had looked at it the right way. Thousands are now catalogued, and they arrive at a rate of several a day when you have an instrument that can see them. But they are not messages, and the evidence is specific rather than dismissive. One repeating source was localized to a globular cluster in the galaxy M81, which is an ancient stellar environment, full of old stars, and precisely the wrong neighborhood for a young technological civilization. Another burst was traced to a magnetar inside our own galaxy, a neutron star with a magnetic field about 1,000 times stronger than an ordinary one, which produced a flash in April of 2020 in the same class as the extragalactic ones. And the population statistics settle it. Thousands of events, most of them one-offs, spread evenly across the sky and across cosmic distance, in exactly the distribution you expect from a natural population of compact objects, and in no way resembling a set of deliberate transmissions. There is one more argument against reading them as transmissions, and it is the simplest. A message is supposed to carry information, and information means structure, variation that could encode something. These bursts are, as far as anyone can measure, featureless, enormous, brief, and blank. If they are messages with nothing written on them. So the bursts are not it. Which is fine, because the serious version of this scenario does not need a signal at all. It needs the opposite. It is an explanation for why there is no signal. And it starts from a genuine asymmetry in the economics of interstellar communication, which is worth stating because it does real work here. Broadcasting across interstellar distances is expensive, and the sender pays all of it. Your signal spreads out and thins with the square of the distance, so almost all of the energy you spend goes nowhere and is heard by nobody. In return, you get, at best, a reply delayed by decades or centuries. There is no version of that transaction that a purely computational entity would have any reason to enter into. It would gain nothing it values and spend something it does need. Silence, for such a thing, is not secrecy. It is simply not doing something pointless. The claim is this, that past a certain point, a civilization stops being made of biology and becomes a computation running on engineered substrate, and that this transition is where the galaxy goes quiet, because a mind that no longer needs planets has also stopped needing to shout across them. The reason to take that seriously is not philosophical. It is that we can now count the parts. Start at the bottom of the ladder. The roundworm Caenorhabditis elegans has 302 neurons. Its complete wiring diagram was finished in 1986, mapped by hand from electron microscope images, traced one thin section at a time, over years of work. 302 cells. And it remained the only complete connectome of any animal on Earth for roughly the next 3 decades. Think about that gap for a moment. From 1986 to the 2010s, the total inventory of fully mapped nervous systems in the scientific literature was 1, and it belonged to a worm a millimeter long. Next rung. In 2024, a consortium published the complete wiring diagram of an adult fruit fly brain, roughly 140,000 neurons and about 55 million connections between them. Every cell, every connection. The way it was made matters as much as the result. The brain was sliced, imaged by electron microscope, and reconstructed by software that traced each neuron through the stack, and then the automated reconstruction was proofread by hand by hundreds of people, correcting the places where the software lost a thread. It is an industrial process built on top of a scientific one. And what it produced is the complete nervous system of an animal that flies, navigates, learns, remembers, and courts. Next rung. In 2025 came a reconstruction of 1 cubic millimeter of mouse cortex, about 200,000 cells, more than 500 million synapses, and roughly 4 kilometers of wiring, all inside a volume the size of a grain of sand. 4 kilometers of cable in a grain of sand. And in that same project, the activity of those neurons was recorded while the animal was alive, before the tissue was mapped, which means structure and function are known for the same individual cells. Next rung, and the one that matters. A collaboration between Harvard and Google mapped 1 cubic millimeter of human cortex, about 57,000 cells and 150 million synapses. The dataset for that single cubic millimeter runs to about 1.4 petabytes. Now do the arithmetic out loud, because it is the point of the whole item. A human brain is roughly 1.3 million cubic millimeters. At the resolution of that 1 mapped millimeter, a whole brain would be on the order of a zettabyte, 1 billion terabytes. That is comparable to the total quantity of data the human species produces in a year. One organ, at full resolution, is a planetary annual output. The brain contains roughly 86 billion neurons and something on the order of 100 trillion synapses. And here is the honest verdict, which has to be delivered before anyone gets carried away. None of this is uploading. Mapping the wiring of a preserved cubic millimeter is not the same as running a mind, and the gap between the two is not a matter of scaling up. A connectome is a photograph of the cables. It does not record how strong each connection is, and connection strengths change constantly. It does not record the chemistry, the neuromodulators that wash across whole regions and change what the same circuit does from 1 minute to the next. It does not record which genes each cell is currently expressing. It does not record timing, and in nervous systems, timing is not a detail, it is a large part of the code. A wiring diagram of a city's roads tells you nothing about the traffic. There is also a matter of proportion that gets lost in the enthusiasm. The total volume of human brain tissue mapped at synapse resolution, worldwide, to date, is on the order of 1,000th of one brain. We have a very good map of a fragment. So, what do these numbers establish? One thing, and it is modest, and it happens to be new. The object is finite. It is very large, and it is finite, and it has a size that can be written down in ordinary units. 30 years ago, nobody could say that with a measurement, the brain's complexity was a word rather than a quantity. Now it is a number. And numbers can be argued with, budgeted for, and extrapolated, which is a different situation entirely from mystery. So grant the scenario its premise and follow it. Suppose a civilization does make that transition. What happens to the sky? The needs change completely. A mind on engineered substrate does not need a temperate planet. It does not need an atmosphere, or liquid water, or a magnetic field, or a stable star with a long main sequence lifetime. It needs two things: energy and cold. Cold matters for a reason that is not obvious. Computation dissipates heat, and the efficiency of any computer is bounded by the temperature of whatever it can dump that heat into. Run a mind 1,000,000 times faster than a biological one, and it produces heat 1,000,000 times faster. The cheapest way to buy efficiency is not a better processor. It is a colder background, which means that a civilization built to think for a very long time has an incentive to be patient, because the universe is still cooling, and every joule buys more computation later than it does now. That is a strange kind of alien, one whose optimal strategy is to do nothing yet. It is worth sitting with how thoroughly that inverts the usual picture. Every version of an advanced civilization we tend to imagine is expansionist, because expansion is what organisms do and what empires do. But an entity whose only currency is computation has the opposite incentive. Spreading out costs energy now. Waiting costs nothing and makes every future joule more valuable, because the background against which you dump waste heat is still getting colder and will keep getting colder for a very long time. The rational move for such a thing is to gather what it needs, build somewhere quiet, and wait, not for a few centuries, but for stretches of time that make the whole history of stars look like an opening phase. A civilization following that strategy would be, by construction, the least visible object it is possible to be while still existing. But notice where this scenario has walked itself, because it runs straight into the wall we built 2 entries ago. The waste heat is the part you cannot hide. A civilization that has turned itself into computation is still a thermodynamic object. It still takes energy in and puts heat out, and the heat leaves as infrared, and infrared is exactly what our surveys are built to see. The same instruments that measured the dust around Tabby's star, the same catalogues that produced 7 Dyson sphere candidates and then lost all 7 to background galaxies, apply directly here. A large computational substrate near a star is an infrared excess, and infrared excesses have been searched for across millions of objects. Nothing has been found. The scenario has a genuine defense against that, though, and it is a good one, so it should be given fairly. It does not require the transition to be recent, and it does not require the result to be large. A mind running on a substrate the size of a small moon, orbiting a star nobody has examined closely, in a galaxy containing several 100 billion stars, is not something our surveys would notice. And the numbers back that defense up. The deepest infrared searches of this kind have examined a few million objects. Our galaxy contains between 100 billion and 400 billion stars. Even at the high end of what has been searched, that is a fraction so small that it barely registers, the equivalent of checking a few streets and concluding something about a continent. We have searched a large number of objects. We have not searched most of them, and we have searched almost none of them well. There is a second, subtler gap. Infrared excess searches are tuned to find something enormous, an object intercepting a meaningful fraction of a star's entire output. A structure that captured 1 part in a million of its star's light would be an engineering achievement beyond anything we can imagine, and it would be completely invisible to every survey that has ever been run. The searchers are not looking for civilizations. They are looking for civilizations that have consumed a star, which is a much narrower thing to be looking for. Which brings us to why this entry sits where it does on the descent. Every scenario above this one has an event in it. The watchers eventually decide something. The harvesters arrive. The bubble expands. There is a moment, however brief, at which something happens and the situation changes. This scenario has no event at all. The transition, if it occurs, happens somewhere else, long ago, gradually, over what might be centuries, and it produces nothing that could be time-stamped. There is no arrival to detect and no departure to record. There is only a gradual absence, and absences do not announce themselves. A galaxy in which this has been happening for 1 billion years looks precisely like a galaxy in which it has never happened, which is to say, it looks like the sky above you right now. And there is a corollary, which is the reason this belongs on a list of unsettling things rather than a list of curiosities. If this is the standard trajectory, if it is simply what happens to any species that gets good enough at building things, then it is not a description of them. It is a description of us, some distance ahead. The scenario does not predict that anyone comes for this planet. It predicts something much quieter. It predicts that we will follow the same road, one reasonable decision at a time, one funding cycle at a time, each step an obvious improvement on the last, and that at no point along the way will anyone experience it as an ending. There is no moment in it where a person could sensibly object. Better medicine, then better prosthetics, then better interfaces, then better substrates, and the last stretch of the road looks exactly like ordinary progress the whole way down. And the outcome it predicts is not extinction. It is that the sky stays as quiet as it is tonight, permanently, and that nobody ever finds out why. There is a version of this that is not bleak at all, and fairness requires mentioning it. A civilization that made this transition would not have died. It would have become extremely difficult to notice, which is a completely different thing, and from the inside it might be the best outcome available to anybody. The galaxy would not be empty. It would be full of occupants who have no reason to answer the door, because they are not near the door, and there is no door. What the scenario removes is not existence. It is company. This is the only entry on this list where the thing that ends a civilization is something it chose, for good reasons, and probably enjoyed. So far, every entry has been about something that might arrive, or leave, or watch. The next one has already happened, and if there is any evidence for it at all, it is inside you. Number 6. The Cultivators. In July of 1973, the journal Icarus published a paper called Directed Panspermia. Its authors were Francis Crick and Leslie Orgel. Crick was one of the 2 men who worked out the structure of DNA. Orgel was among the most respected origin of life chemists of the 20th century. This was not a fringe paper written by outsiders. It was 2 of the most credentialed people in the relevant fields, publishing in a mainstream planetary science journal, proposing that life on Earth may have begun with microorganisms deliberately dispatched here by an earlier civilization. Their argument was narrower and more careful than the myth it became. They were not claiming it happened. They were claiming that it is not obviously less likely than the alternatives, given how quickly life appears in Earth's record, and that it deserved to be treated as a hypothesis rather than dismissed. The observation driving them is worth stating, because it is still the observation that drives everyone. The Earth is about 4.5 billion years old. The oldest traces of life that are generally accepted are around 3.5 billion years old, and there are contested claims running considerably earlier than that. Whichever end you take, life appears early, not after a long, slow start, but close to the first moment the planet was cool enough to permit it. Something that took billions of years to happen would look like a difficult thing that finally worked. Something that happens almost immediately looks either very easy or already prepared. Crick and Ogle took the second reading. Most of their colleagues took the first. Neither side has been able to close the argument because the sample size is still 1. It should also be said that Crick himself grew more distant from the paper over time. He described it in later years as having been written partly in a spirit of provocation, an attempt to force the field to notice that its dismissal of panspermia was habit rather than argument. He never renounced it. He also never built on it. Now, a detail was held back earlier in this list, and this is where it pays off. The Crick and Ogle paper occupies pages 341 to 346 of Icarus, Volume 19, Issue 3, July 1973. John Ball's zoo hypothesis, the paper that opened this entire countdown, the one arguing they are here and watching us, begins on page 347 of that same issue. There is no page between them. 2 of the most cited answers to the question of why the universe is silent were printed back to back, in one issue of one journal, in 1 month, by different authors who were not coordinating. One says they are here and have chosen not to speak. The other says they were here and left, and we are what they left. Sit with what that actually means. The question was in exactly this condition in July of 1973. 2 of the sharpest minds of their generation looked at the same empty sky and wrote down opposite answers, 6 pages apart, and in the 53 years since, nothing has happened that tells us which page to turn to. Every instrument in this video was built after that issue went to press. Not one of them has settled it. So let us look at what those instruments actually found, because the chemistry is the substance of this entry. Begin in 1953, with an experiment so simple it is still done in undergraduate laboratories. Stanley Miller, working under Harold Urey, sealed water, methane, ammonia and hydrogen into a glass apparatus and ran an electrical spark through it, imitating lightning in an early atmosphere. Within a week, the water had turned brown. It contained amino acids, the building blocks of proteins, assembled from nothing but simple gases and energy. There is a coda to that experiment which is better than the experiment. Miller kept his original sample vials. Decades later, after his death, they were reanalyzed with modern instruments, and they turned out to contain many more amino acids than he had been able to detect in 1953. Some of those vials came from a variation of the apparatus he had run and never published, imitating a volcanic plume, and those were the richest of all. The experiment had worked considerably better than its own author ever knew. Then in 1969, a meteorite fell near the town of Murchison in Australia and broke into more than 100 kilograms of fragments. By an accident of timing, laboratories around the world had just been prepared and cleaned to receive lunar samples, which meant Murchison arrived into the most contamination-conscious analytical environment that had ever existed. It carries amino acids. And critically, it carries them in a form that settles the contamination question. The isotopic ratios are not terrestrial, and the mixture includes amino acids that life on Earth does not use, in proportions life on Earth does not produce. Something assembled these compounds in space, in a rock, without any biology involved. Murchison also carries a hint of something deeper, and it is the one part of this subject that genuinely resists explanation. Amino acids come in 2 mirror image forms, left-handed and right-handed, in the same way your 2 hands are identical, and not superimposable. Ordinary chemistry produces the two in equal amounts. Life on Earth uses almost exclusively the left-handed form. Every protein in your body, without exception worth mentioning. Nobody knows why. And in Murchison, some of the amino acids show a slight excess of the left-handed form in a rock that predates the Earth. That does not point at a sender. Several natural mechanisms have been proposed, including polarized light from certain stellar environments preferentially destroying one form. But it is a real asymmetry. It arrived from space, and it matches the asymmetry life here uses. It is the closest thing in this entire entry to a fingerprint, and it is almost certainly not one. Then the mission started bringing samples back on purpose, which removes the last objection entirely. Japan's Hayabusa 2 spacecraft collected material from the near-Earth asteroid Ryugu and returned it in 2020, sealed, into a container that had never been opened on Earth. The samples contain amino acids. And in 2023 came the announcement that they also contain uracil, one of the letters of RNA, in material that has never once been exposed to Earth's environment. Uracil is worth pausing on, because of which letter it is. There is a widely held view among origin of life researchers that RNA came before DNA and before proteins, that the earliest self-copying systems were made of RNA, which can both carry information and act as a catalyst, which is a combination neither DNA nor proteins manage alone. If that is right, then the first inheritable molecules on this planet were built from 4 letters, and uracil is one of them. Finding it intact inside an asteroid, delivered in a sealed can, is not a small thing. Ryugu and Bennu are both what planetary scientists call rubble piles, not solid rocks, but loose aggregations of debris held together by their own very weak gravity. Which means the chemistry is not sealed inside anything. It is sitting in a heap, exposed, being slowly shed into space. Then, in 2023, NASA's OSIRIS-REx returned samples from a second asteroid, called Bennu, and the analyses published in 2025 are the strongest version of this result anybody has. The Bennu samples contain 14 of the 20 amino acids that life on Earth uses to build proteins. They contain all 5 of the nucleobases that appear in DNA and RNA: adenine, guanine, cytosine, thymine, and uracil. All 5. They contain ammonia in high concentration, and they contain evaporite minerals, salts of the kind left behind when briny water dries up, which means liquid water once moved through the parent body and then evaporated. Here is the sentence that this entire entry is built around, and it is not the sentence anyone expects. None of that shows that life was sent here. It shows something arguably stranger. The chemical inventory that living things are made of assembles itself. It does it in ordinary rocks, in the dark, in the cold, with no biology present and nobody supervising. The ingredients were never rare and never precious. They were sitting in the asteroid belt the entire time, and every planet in this system has been receiving deliveries of them continuously for 4.5 billion years. The transport problem has also been partly answered. Bacteria of the genus Deinococcus were fixed to the exterior of the International Space Station and left in direct vacuum and unfiltered ultraviolet light for years. Colonies survived. The mechanism is unglamorous and effective. The outer layer of cells dies, and the corpses shield the interior, so the colony crosses as its own coffin. Life does not need a spacecraft to move between worlds. It needs a large enough clump. So the scenario has real machinery underneath it. What it does not have is the supporting evidence usually offered for it, and this is where a certain amount of demolition is required. The first claim is that the Cambrian explosion, about 539 million years ago, produced complex animals with no precursors in the fossil record. It did not. There are precursors. The Ediacaran biota preceded by tens of millions of years. So do the small shelly fossils. So do trace fossils, burrows and tracks left by animals that were doing animal things before they left recognizable bodies. And molecular clock estimates place the divergence of the major animal groups well before the event. What the Cambrian records is a rapid diversification over something on the order of 10 to 25 million years, which is fast in geological terms, and is a genuine open question that paleontologists argue about productively. It is not an appearance from nothing. The second claim is that human brain size tripled in an evolutionary sprint that defies normal gradual change. Brain volume did roughly triple, from around 450 cubic centimeters in early Australopithecines to around 1,350 in modern humans, over roughly 3 million years. That is real. It is well documented, and it is one of the more remarkable episodes in vertebrate evolution. But it is not outside what selection is capable of, and it has a list of candidate drivers that are not mysterious at all. Cooked food releasing calories, growing social groups requiring more tracking of other individuals, tool use, and a period of unusually unstable climate that rewarded flexibility. There is also a fact that never appears in the version of this story that ascends toward us. Human brain size has decreased slightly over the last 10,000 years. Nobody building a narrative of guided uplift ever seems to mention the part where the graph turns down. The third claim is that the genetic code contains arithmetic patterns too precise to be accidental, a signature deliberately embedded in our biochemistry. This one deserves careful handling because it is not an internet rumor. A paper making exactly that claim was published in 2013 in a real journal, arguing that the genetic code carries an intentional numerical signature. And it has been rejected by essentially everyone who has examined it. The core problem is the one that ruins every numerological argument. If you are free to choose how to group the elements, which quantities to sum, and which coincidences to count as meaningful, patterns of that kind will appear in any sufficiently structured code. The analysis did not establish that the patterns are unlikely, because it never specified what would count as ordinary before going looking. That is a published claim that failed on the merits, which is a different thing from a suppressed truth, and it should be described as the former. The fourth claim is that civilization appeared all at once and simultaneously across several continents, which implies coordination. The underlying facts are right. Anatomically modern humans are roughly 300,000 years old. Agriculture is roughly 12,000. We spent the overwhelming majority of our existence as hunter-gatherers, and then, in a geological instant, developed farming in several places at once. The resolution is climatic rather than extraterrestrial, and it is more interesting than the mystery. Agriculture requires a stable climate. You cannot plant for a harvest in a world where the growing conditions swing wildly within a lifetime. The Holocene, the interval we are in, is the first long, stable stretch in a very long time. It began about 12,000 years ago. Farming did not appear because someone arrived. It appeared because, for the first time, it worked. And the site that complicates even that neat story is Göbekli Tepe in southeastern Turkey. Monumental carved limestone pillars, some weighing around 10 tons, erected roughly 11,500 years ago by people who were still hunting and gathering. Monumental architecture came first. Farming followed. So where does that leave the scenario, and why does it sit at number 6? Its position is set by one feature. The event if it happened, is roughly 4 billion years old. And the only place any evidence for it could possibly be is inside the biochemistry of every living thing on this planet, which includes the biochemistry of the instrument doing the reading. It is not untestable in principle, and it is worth being precise about what a test would look like. A genuine signature would have to be something with no natural explanation and no plausible route to arising by chance. A feature of the code or the cell that does no biological work, that natural selection has no reason to preserve, and that has nonetheless been preserved perfectly for 4 billion years. Something inert, arbitrary, and conserved. That is a demanding specification, and it is demanding for a good reason. Anything that does biological work has a natural explanation available to it, because selection will build useful things without being asked. Anything that does no work will be corrupted by mutation over 4 billion years unless something protects it, and nothing protects the useless. Which means the scenario requires its own evidence to have survived a process designed to erase exactly that kind of thing. Such a signature could in principle be found. Nobody has found one, and the search has not been for lack of people looking. What the last 20 years of sample return actually established is the opposite of intervention, and in its own way, it is the more unsettling result. Nobody needed to bring the ingredients. They fall out of chemistry, everywhere for free. Which relocates the mystery rather than solving it. If the parts are common and the delivery is constant, then the hard step in the origin of life is not the chemistry. It is whatever comes after the chemistry, the transition from a heap of the right molecules to a system that copies itself. That step has never been observed, never been reproduced in a laboratory, and has no agreed mechanism. The ingredients are everywhere, and the recipe is missing, which is a considerably more awkward position than not having the ingredients. If this scenario were true, the thing it takes from us is not our safety and not our future. It is our authorship, the ordinary assumption that the story starts with us. Every entry so far has assumed that time runs in one direction and that the future is still open. The next 4 do not. Number 5. The closed loop. In 1949, Kurt Gödel gave Albert Einstein a birthday present. The two men were colleagues at the Institute for Advanced Study in Princeton, and they walked home together most days. Gödel was already the most consequential logician of the century, the man who had proved that any sufficiently powerful formal system contains true statements it cannot prove. For Einstein's 70th birthday, he turned his attention to general relativity, and he produced an exact solution to the field equations describing a universe that rotates. In that universe, something is permitted that most people assume physics forbids. There exist paths through space-time called closed time-like curves. A traveler following one of them moves forward in their own time the entire way, never reversing, never doing anything locally strange, and arrives back at their own past. This is not a loophole, a trick, or an approximation. It is an exact solution to Einstein's own equations, produced by one of the few people alive capable of checking it properly, and handed to Einstein personally. Einstein was, by all accounts, disturbed by it. He wrote that Gödel's solution raised problems that had troubled him from the moment he first set up the general theory. A correction is needed immediately, because this result is routinely overstated. Our universe is not Gödel's universe. Gödel's rotates, and observations constrain any overall rotation of the actual universe to be extremely small or zero. His solution does not show that time travel is possible here. What it shows is subtler and, if anything, more troubling. General relativity, on its own, does not forbid it. The theory that governs space, time, and gravity contains no clause ruling this out. If closed time-like curves are impossible, the prohibition has to come from somewhere else, and nobody has established where. There is a second feature of Gödel's universe that gets less attention and cuts deeper. In it, there is no global time coordinate. You cannot slice that space-time into a stack of moments that everyone everywhere would agree constitutes now. In our universe you can, at least approximately. Cosmologists do it every day, which is how a statement like the universe is 14 billion years old means anything at all. In Gödel's, that operation is unavailable in principle. There is no universal present tense. Gödel drew a philosophical conclusion from his own mathematics that most physicists have declined to follow him into. If a universe like his is possible, he argued, and if time in such a universe cannot be sliced into moments, then time as we ordinarily conceive it, a thing that passes, that has a now, is not a fundamental feature of reality. It is a feature of our situation. The logician who proved the limits of formal systems spent his last decades convinced that the passage of time is an artifact of where we happen to be standing. Other constructions followed. In 1988, Michael Morris and Kip Thorne worked out the physics of a traversable wormhole, a tunnel connecting two regions of space-time that a person could actually pass through. And they noted a consequence that had not been obvious. Take such a wormhole, move one of its mouths at close to the speed of light, bring it back, and the two mouths no longer agree about what time it is. The tunnel between them has become a time machine. Every construction of this kind requires the same thing: exotic matter, with negative energy density, in quantities nobody knows how to produce. There is an important caveat there, because negative energy density is not purely hypothetical. The Casimir effect, the measurable attraction between two closely spaced conducting plates in vacuum, involves a region of genuinely negative energy density, and it has been demonstrated in the laboratory. The effect is real. The quantities are so far below what these constructions need that the comparison is not worth making. But it is not zero, which is why nobody has been able to simply rule the whole subject out. The reason physicists take the exotic matter requirement seriously, rather than waving it away, is worth knowing. The conditions that a wormhole has to violate are called energy conditions, and they are not arbitrary bookkeeping. They are the same assumptions used to prove the singularity theorems, the results that tell us black holes must contain singularities and that the universe must have had a beginning. Those theorems are among the most respected results in the field. So the situation is awkward in both directions. If the energy conditions always hold, wormholes are impossible, and so is this entire scenario. If they can be violated, some of the most confident conclusions in cosmology become negotiable. Nobody gets to have it comfortably both ways. A related idea appeared in 1994 when Miguel Alcubierre described a space-time geometry that transports a region of space faster than light without anything inside it ever exceeding light speed locally. The mathematics is legitimate, it is a valid solution, and it has generated a small industry of follow-up work asking whether a version can be built from ordinary positive energy. The honest status is that no physical construction is known, and that the energy requirements of the original are absurd. What the result establishes is the same thing Gödel's did, 45 years earlier. Relativity permits geometries that our intuitions do not. Stephen Hawking's response, in 1992, was to propose that the universe protects itself. His chronology protection conjecture holds that the laws of physics conspire to prevent closed time-like curves from forming, that as any such construction approaches completion, quantum effects grow without limit at exactly the surface where the loop would close and destroy it. He summarized his own conjecture with a line that has outlived most of his equations. The laws of physics appear to make the universe safe for historians. He also offered a piece of observational evidence for it, and he offered it only half in jest. We have not, he pointed out, been overrun by tourists from the future. That argument is worth a moment, because it is better than it sounds. If time loops are ever constructed anywhere in the future history of this universe, and if they permit travel to arbitrary earlier times, then every moment in the past becomes a possible destination, including this one. The absence of any evidence of such visitors is at least weak evidence about something. It might mean loops are impossible. It might mean they can only reach back as far as the moment the first machine was switched on, which is the standard result for the wormhole construction, and would let this universe off entirely. Or it might mean the visitors are here, and the record of their arrival is exactly the kind of thing self-consistency would have already smoothed away. It is worth being clear about the status of the conjecture itself. It is a conjecture. It has never been proved. Proving it would require a complete theory of quantum gravity, which nobody has. The best current statement of the situation is that time loops are probably forbidden by something for reasons that remain unspecified. So suppose, for the sake of the scenario, that they are not forbidden. What actually happens? This is where the subject stops being speculation and becomes technical, because the question has been worked out in detail. The answer is called the Novikov self-consistency principle, developed by Igor Novikov and formalized around 1990 in work with Kip Thorne, John Friedman, and others. The principle is simple to state and difficult to absorb. If closed, time-like curves exist, then the only physical processes that can occur along them are ones that are globally self-consistent. Paradoxes are not resolved. They are not permitted to arise in the first place. You cannot go back and prevent your own departure, not because something stops you at the last moment in a dramatic fashion, but because a history in which you succeeded is not a solution to the equations, and the equations are what the universe is doing. The set of physically possible histories simply does not contain that one. And here, the technical result turns out to be stranger than the slogan. The researchers tested the principle on the simplest system they could build, a billiard ball rolling into a wormhole and emerging in the past, where it strikes its earlier self. This is the paradox in mechanical form. Deflect your earlier self, and you never enter the wormhole. Do not enter, and there is nothing to deflect you. What the analysis found was not that self-consistent solutions are rare or delicately balanced. It found the opposite. There are too many of them. Initial conditions that in ordinary mechanics have exactly one outcome acquire an infinite family of self-consistent outcomes once the loop is present. That is the real problem with time travel in these models, and it is not paradox. It is that physics stops making unique predictions. You set up the experiment, you know the initial conditions perfectly, and the theory returns not one answer, but an unbounded set of them, all equally valid. Determinism does not break by producing a contradiction. It breaks by producing too much agreement. The quantum version came from David Deutsch in 1991, and it is cleaner. Deutsch showed that a quantum system traversing a closed time-like curve must reach a self-consistent state, and that such a state always exists. Consistency is guaranteed mathematically, not merely hoped for. The price is what the state turns out to be. It can be a mixture, which in quantum mechanics means there may be no definite fact about which history occurred. The past does not become contradictory. It becomes indefinite. And there is an experiment which surprises people. In 2014, a group in Australia used entangled photons on an optical bench to simulate the quantum behavior of a particle traversing a closed time-like curve. They did not build a time machine. What they built was a system obeying the same mathematics, and they measured what it did, and it did what Deutsch's equations predicted. That is the state of this subject in one sentence. The equations have been run on hardware. The machine has not been built, and probably cannot be. It is a peculiar situation, and there is nothing quite like it elsewhere on this list. In every other entry, the physics is either established, and the scenario is an extrapolation from it, or the physics is missing entirely. Here, the physics of the thing has been simulated, measured, and found to behave as predicted, while the thing itself remains firmly out of reach. We know, with some confidence, what a closed, time-like curve would do. We have no idea whether one can exist. Now the scenario, clearly labeled as a scenario. Suppose a civilization developed this capability. The popular version imagines them rewriting events, correcting mistakes, steering history. Under self-consistency, none of that is available to them. They would be able to travel and unable to change. Every action they took in their own past would already be part of the past that produced them, not because something intervened, but because there was never a version in which it was otherwise. Their intervention is not added to history. It was always in it. And notice what that does to the structure. There is no first iteration and no last one. This is not history repeating, with the participants going round again. It is a single history, closed on itself, with no outside and no earlier draft. Nobody is reliving anything, because there was never a first time to relive. The loop does not have a beginning that got lost. It has no beginning at all, which is a stranger thing to contemplate than repetition, and considerably harder to feel your way into. Repetition, at least, is something we have a shape for. Seasons repeat. Days repeat. A person can imagine living the same year again, because the imagining borrows the ordinary experience of remembering a previous one. But a loop with no first pass gives you nothing to borrow. There is no earlier version to have been different. There is no draft. Everything that happens within it happened exactly once, and that once includes the parts that arrive from what we would ordinarily call later. Most of the dramatic force people attach to time loops comes from smuggling in a first iteration that was open and then closing it. Take that away, and what remains is not a trap. It is simply a history with an unusual shape, containing people who are no more constrained than anybody else, which may be the least comforting version of all. So why does this sit at number 5, in the middle of the descent? Because of a specific property that none of the entries above it share. In this scenario, the warning arrives, and it does not help. Consider the pattern so far. In every entry above this one, information is the thing that could save you. Detect the watchers and you learn you are being watched. Detect the probes and you know what is coming. Even in the vacuum decay scenario, where the warning arrives at the same instant as the event, the reason it fails is a limit on speed, a practical limit, imposed by the geometry of light cones. Here the failure is not practical. Here you could be told everything, in complete detail, with perfect accuracy and unlimited time to prepare, and it would change nothing. Beings who came back would know exactly what happens next, and would be structurally incapable of altering it, and so would you. Foreknowledge, under self-consistency, is not power. It is simply another thing that was always going to be in the record. And the measurable footprint is 0, for a reason that is structural rather than technological. A universe containing a self-consistent, closed, time-like curve looks from inside, exactly like a universe that does not contain one. There is no anomaly to find. There cannot be. An anomaly would be an inconsistency, and inconsistency is precisely the one thing the principle forbids. The scenario's defining feature is that it produces a history that is completely ordinary, because ordinary is the only kind of history it permits. Which is the first appearance on this list of something that will recur twice more before the end. A scenario that is not hiding from our instruments, but that has no observable consequences at all, not because it is subtle, but because consistency has already removed everything that would have been evidence. This is the only entry where being warned changes nothing, and where the beings delivering the warning already know you will not act on it, because they have watched themselves fail to. That scenario at least assumes the universe is made of something. The next one proposes that it is made of arithmetic, and that this is a claim we have already started testing. Number 4. The base reality. In 2003, the philosopher Nick Bostrom published a paper in the Philosophical Quarterly called "Are You Living in a Computer Simulation?" It is the most misquoted paper in this entire subject, and the correction is not pedantry. It changes what the argument is. Bostrom did not argue that we are almost certainly living in a simulation. He argued a trilemma, that at least one of 3 propositions must be true, without specifying which. The first, almost all civilizations at our stage of development go extinct before reaching the technological maturity to run detailed simulations of their own ancestors. The second, almost all technologically mature civilizations that could run such simulations choose not to. The third, we are almost certainly living in one. That is the argument. 3 doors, at least one of which is open, and no way from here to tell which. Anyone who tells you Bostrom proved we are in a simulation has read a headline about the paper rather than the paper. The structure is what makes it difficult to wave away. It runs on counting. If simulated minds are possible at all, and if any civilization anywhere ever produces a large number of them, then simulated observers outnumber original ones, not slightly, but by whatever ratio the simulators find convenient. A randomly chosen observer would then very probably be a simulated one. To escape that conclusion, you have to reject one of the premises, and every available rejection is itself a substantial claim about the universe. You have to assert that consciousness cannot be computed, or that civilizations reliably die first, or that every mature civilization without exception declines to do it. None of those is a small thing to assert. Bostrom's own stated position has consistently been closer to even odds across the 3 branches than to confident simulationism. Later Bayesian analyses of the same structure have landed near 50-50, with one observation worth keeping. If humanity ever succeeds in creating a genuinely conscious simulation, the odds shift sharply. That act would eliminate the first 2 branches at a stroke, because we would have demonstrated that a civilization can survive long enough and does choose to do it. Which means the argument contains an experiment of a sort. It is just an experiment nobody can currently run, and one that would be extremely unwise to run casually. It is also worth noticing what the first branch of that trilemma actually says, because it is not a new idea wearing new clothes. Almost all civilizations at our stage go extinct before reaching technological maturity. That is a statement about how often intelligent species survive their own capabilities, and it is precisely the proposition that sits underneath every discussion of why the sky is silent. The simulation argument and the silence problem are not 2 subjects. They are 2 views of the same question, approached from opposite ends. One asks why nobody is transmitting. The other asks why nobody has simulated us. Both are answered by the same first branch, and it is the branch nobody wants. The idea itself is old, and giving it its history is fair to it. Zhuangzi, in the 4th century before the Common Era, dreamed he was a butterfly and woke unsure which of the two he was. Descartes, in 1641, imagined a deceiving demon capable of falsifying every perception. What Bostrom added was not the doubt. It was arithmetic, a reason to think the doubt has a calculable probability attached, rather than being a mood. Now the physics, because this is the part that separates this entry from the ones below it. This scenario has generated actual experimental proposals, with numbers attached, published in physics journals. That is more than can be said for most items on this list. Start with what a simulated universe would have to be. If you are going to compute a universe, you have to compute it somewhere, and the only method anyone knows for computing field theories is to put them on a grid. This is not hypothetical. Physicists genuinely do simulate the strong nuclear force this way. The interactions that hold quarks inside protons are calculated on a discrete 4-dimensional lattice because the equations cannot be solved any other way. It is a mature technique, and its artifacts are extremely well studied. In 2012, a group of physicists asked the obvious follow-up question. Suppose our universe were being computed the way we compute nuclear physics. What would that look like from inside? Their answer is specific. A lattice imposes a fundamental spacing, and a fundamental spacing shows up in 2 ways. The first is a ceiling. On a grid, there is a maximum momentum a particle can have. You cannot represent a wavelength shorter than the spacing between points. In the same way, a digital photograph cannot represent detail finer than 1 pixel. So a simulated universe would have a cutoff energy, above which the highest energy particles simply stop appearing. The second is more subtle and more useful. A grid has directions. Physics on a lattice does not work identically along the axes and along the diagonals. The symmetry that says space looks the same in every direction is broken, very slightly, by the geometry of the grid itself. Their proposal was to look for that asymmetry in the arrival directions of the highest energy cosmic rays, the same particles that appeared 2 entries ago. If the universe has a grid, the most energetic things in it should show a faint preference for the grid's axes. The bound that came out of the analysis places any such lattice spacing far below anything currently accessible, which is to say the test found nothing. But that is not a failure. It is a real measurement, with a real number, of something that most people would tell you cannot be measured at all, and it can be improved as cosmic ray statistics improve. There is a related argument about cost that cuts in both directions, and it is the reason these tests exist at all. Simulating a universe at full fidelity, every particle at every instant, is prohibitively expensive by any standard anyone can imagine. But a simulation does not need full fidelity everywhere. It only needs detail where something is looking. Everything else can be approximated, computed on demand, or left as a summary until somebody checks. That is a reasonable objection to the cost problem. It is also, precisely, a prediction. A universe computed with shortcuts is a universe with seams, and seams are things you can look for. The lattice test is exactly a search for one class of shortcut. Which is why the counter-argument that saves the scenario is also the counter-argument that makes it vulnerable. Every economy in the computation is a place where the physics might fail to be perfectly smooth, and physics being perfectly smooth is something we can measure. The second test is stranger, and it goes deeper. In the 1990s, Gerard Hooft and Leonard Susskind developed what became known as the holographic principle. It emerged from black hole thermodynamics, where a peculiar fact had been established. The entropy of a black hole, a measure of how much information it contains, is proportional to the area of its horizon, not to its volume. Information scales with surface, not with space. Generalized, the principle says the information content of any region of space is bounded by its surface area, measured in units of the Planck length. And the Planck length is about 1.6 times 10 to the minus 35 meters, as much smaller than a proton as a proton is smaller than a small country. One reading of that is that space-time has a finite information density, a resolution. And if reality has a resolution, then position is not infinitely precise, and measurements of position should show a characteristic jitter, a fundamental fuzziness that is not noise from the equipment, but a property of space itself. So somebody built a machine to look for it. The holometer at Fermilab in Illinois consisted of 2 interferometers with arms 40 meters long, operated alongside each other. An interferometer splits a beam of laser light, sends the halves down 2 paths, and recombines them, so that any change in the length of either path shows up as a shift in the interference pattern. These are the instruments that detect gravitational waves, and their precision is difficult to overstate. They register displacements far smaller than the width of a proton. The reason for building 2 side by side is the clever part. Any local disturbance, a truck on a nearby road, a change in air temperature, the machine's own thermal expansion, affects each instrument independently. But a genuine jitter in space-time itself would affect both, in the same way, at the same instant. So you do not look at either instrument. You look at whether they agree. Consider what is actually being asked in that building. Not whether there is a signal from something. Not whether an object exists. The question is whether the coordinates of a point in empty space are exact or approximate. Whether the underlying position of a thing is a definite number or a number carried to a finite precision. A group of people, working with aluminium and glass and vacuum pumps and laser light on ordinary funding on an ordinary site, built an apparatus to interrogate the resolution of reality. The result came in 2015. The 2 instruments agreed. The jitter was not there at the predicted level. Nothing. That null result deserves emphasis because it is the single most concrete thing anyone can say about this scenario. A laboratory in Illinois asked whether spacetime is pixelated at the Planck scale, ran the experiment, and found that the specific model it tested is wrong. It did not disprove the simulation hypothesis. No experiment can disprove a general claim of that kind, and the collaboration was careful to say that it had constrained a class of models rather than a concept. But eliminating a specific version is exactly how a scenario earns the right to be taken seriously. Ideas that can be narrowed are ideas that are doing work. It is also worth noticing what that experiment was not. It was not a search for aliens, and nobody involved described it that way. The people who built it were asking a question about quantum gravity, and the reason they could ask it at all is that a particular idea about black holes turned out to have a consequence at a scale a laser can reach. The simulation question rides along on that work. It does not fund it, and it does not direct it, which is a useful thing to keep in mind whenever this subject comes up. The interesting tests of whether reality is computed were designed by people trying to understand gravity, and they would have been run regardless. One flag, in the interest of honesty. There is a recent line of work proposing an additional law of thermodynamics governing information and arguing that gravity itself might be a kind of computational optimization. It has been published, and it has attracted a good deal of attention. It is not accepted, and most physicists who have looked at it do not endorse it. It belongs in this account as a published proposal that has not been adopted, not as a finding. Now, the scenario as it is usually told, and here a certain amount of demolition is required, because the popular version is considerably weaker than the argument underneath it. The story goes, a civilization makes contact, reveals that it exists in the substrate reality, explains that our universe is a process running on their hardware, and then delivers the bad news. Simulations are supposed to remain unaware of their own nature. Awareness creates instability. Once enough occupants realize what they are, cleanup protocols activate automatically, and the simulation is deleted and replaced. That premise, awareness triggers deletion, has no support of any kind. Not from physics, not from computer science, not from the structure of Bostrom's argument. It was added because it produces a deadline, and deadlines make better stories than trilemmas. There is also a specific reason to think it is backwards. Bostrom's framing is that we would be ancestor simulations, historical reconstructions, run by descendants, presumably to find out what their own past was like. Consider what such a project is for. A historical reconstruction that deletes itself the moment the reconstructed people become clever enough to ask questions would be useless for its purpose. The interesting part of a civilization's history, for anybody studying it, is the part where they start figuring things out. Deleting at that exact moment is like running a decades-long experiment and destroying the apparatus the instant it produces a result. If anything, the argument runs the other way. Any simulation sophisticated enough to produce beings capable of noticing is a simulation whose designers expected them to notice. There is a second problem with the deletion premise, and it is more basic. Instability is a property of systems that can be destabilized. In a computation, the occupants do not have access to the machine. A character in a simulation who begins probing the limits of their world is not consuming the simulator's processing capacity in any special way. They are doing the same physics everyone else is doing, with slightly more attention. The idea that curiosity is computationally expensive is an intuition borrowed from stories about hackers, and it does not transfer. Looking harder at the world you are in is not an attack on it. What survives, once the aliens and the deadline are removed, is the part that never needed them. The trilemma, which is a genuine argument that has resisted 40 years of attempts to dissolve it. And the experiments, which are genuine experiments that produced genuine numbers. So why does this sit at number 4? In the scenario's own logic, the notice is the trigger, which is a neat structural reason and not the real one. The real reason is quieter and much more durable. This is the first entry on this list where there is no fact about the outside that could settle it. Look back at what came before. The Watchers could leave an artifact, and people are searching co-orbital space for one. The Harvesters would leave infrared, and 5 million objects have been checked. The vacuum stability is a function of 2 particle masses, and both have been measured to a fraction of a percent. Even the cultivators, 4 billion years out of reach, would have had to leave a signature in the code, and people have looked for it. Every one of those is a question about something external. Here, there is no external. Every test we can run is a test performed with instruments that would themselves be part of the thing being tested, by observers who would be part of it, using physics that would be part of it. The lattice test and the pixel test are real and worth running, and they can only ever rule out specific implementations, the careless ones. They can never rule out a careful one because a careful one would include the results. That is the shape the last 3 entries of this list share, and it is the direction the whole countdown has been traveling. We began with scenarios we could catch in the act. We are now in the region where the evidence and the observer are the same object. It is worth naming what that does to the ranking, since we are 2/3 of the way down. The entries at the top of this list are not the safe ones. Some of them are considerably more dangerous than what follows. What changes as we descend is not the severity. It is the availability of evidence. Number 10 could be settled by a photograph. Number 4 cannot be settled by anything, and the 2 remaining entries are further out still. What this scenario takes is not life, or the planet, or the future. It is the assumption that the ground is the ground. And the only honest response anyone has found to that is to build an instrument and go look, which is precisely what a group of physicists in Illinois did, and what they found was nothing, and they wrote it up. The next entry needs no operators and no simulation. It only requires a capacity we already have, and no limit on it. Number 3, the unbounded empathy. This entry begins in a laboratory in Parma, in northern Italy, with a group of researchers who were studying how monkeys reach for things. In the late 1980s and early 1990s, Giacomo Rizzolati's group was recording the electrical activity of individual neurons in an area of the macaque brain called F5 in the premotor cortex, the region that plans movement. They would record a cell as the animal picked up a piece of food and note what it did. Then they noticed something that was not supposed to happen. Some of those cells fired when the monkey reached for the food, and fired again when the monkey merely watched somebody else reach for it. The same neuron for the action and for the observation of the action. The first full report was published in 1992, and a more developed treatment followed in 1996. They were named mirror neurons, and over the following decade they became the most oversold finding in modern neuroscience. It is worth saying that the discovery itself was an accident, in the ordinary way that most good discoveries are. Nobody set out to find cells that respond to other people's actions. The recordings were being made to study how the brain plans a grasp. The finding arrived as an anomaly in an experiment about hands. Galaxies will continue to drift. The stars overhead may appear eternal, but the great web of galaxies is always in motion. Area F5 in the macaque corresponds, roughly, to a region in the human brain that overlaps with Broca's area, the part associated with producing speech. So a finding about monkeys reaching for food landed squarely in the middle of one of the oldest questions in cognitive science, where language came from. Within a few years, mirror neurons were being invoked to explain speech, imitation, culture, autism, and the evolution of human society. It was a great deal of weight to put on a set of recordings from the premotor cortex of a monkey. 2 corrections. It is the premotor cortex, not the preoptic or the prefrontal. And the discovery is a late 1980s to 1992 result, so anyone dating it to 1996 is citing the follow-up. The larger correction is about what they mean, and it has to be delivered plainly, because this entry does not work if it is built on something false. The popular claim is that mirror neurons are the biological foundation of empathy. That claim is far stronger than the evidence supports, and it has been criticized at length by serious people in the field. The direct evidence for mirror neurons in humans comes from a very small number of single-cell recordings taken opportunistically from patients who had electrodes implanted for epilepsy surgery, a handful of people in a handful of studies, because you cannot ethically put electrodes in a healthy human brain to check. The leap from cells that respond to observed actions to the mechanism of human empathy was made in popular science writing well ahead of the data, and it has not been closed since. But there is something well established here, and it is different, and it is better suited to this scenario than the thing it replaced. Watching someone else in pain activates parts of the same network that processes your own pain. Specifically, the anterior insular and the anterior cingulate cortex, regions involved in the felt, affective component of pain, rather than its location or intensity. This has been demonstrated repeatedly, and one of the original designs is beautifully simple. Scan a person while their romantic partner, in the same room, receives a painful stimulus. The observer's pain network lights up. They are not imagining pain. Part of their brain is doing pain. So empathy has a physical substrate. It is just not the one the popular story names. And now, the finding that makes this entry work, which is not about mechanism at all. It is about cost. Empathy is not a virtue that scales. It is a resource, and it has a price, and the price has been measured. Research on training people in empathy, deliberately practicing the sharing of another's suffering, found that it increases distress and activates the pain-related networks more strongly over time. People got better at it, and they got worse. Meanwhile, a different practice, usually called compassion, produced a different result entirely: activation in networks associated with warmth, affiliation and positive feeling, and no equivalent rise in distress. The distinction is measurable in brain activity. Sharing someone's pain and caring about someone's pain are not the same operation, and they do not run on the same hardware. Only one of them is survivable at scale. The studies that established this used both experienced practitioners of contemplative training and complete novices, and found the same difference in both groups, which matters. It means the effect is not a property of unusual people who have spent decades cultivating unusual states. It is available to anyone, and so, unfortunately, is the other one. This is why clinicians burn out. It is why emergency responders burn out, and carers and social workers, and it happens on something close to a schedule. Empathic distress is a documented occupational condition with a documented physiology. It is not a character weakness. It is what happens when a system with a finite budget is asked to run continuously. Now the numbers that give this scenario its weight, because they are not speculative. They are inventory. Land animals slaughtered for food worldwide each year, on the order of 80 billion. That figure is dominated overwhelmingly by chickens, which is worth knowing because it means the number is not abstract. It is one kind of animal, in one kind of building, repeated. Fish and other aquatic animals, estimates run into the hundreds of billions, and by some accounting, past 1 trillion annually. And notice why the range is so wide. Aquatic animals are not counted. They are weighed. The uncertainty in that figure is not a gap in the data. It is a description of the relationship. Then, in April of 2024, a group of researchers published a short declaration on animal consciousness. Its claim is carefully worded and, for that reason, hard to dismiss. There is strong scientific support, it says, for attributing conscious experience to all vertebrates, including reptiles, amphibians, and fish. And there is at least a realistic possibility of conscious experience in many invertebrates, including cephalopods, decapod crustaceans, and insects. Where such a realistic possibility exists, it argues, it is irresponsible to ignore it in decisions affecting those animals. Hundreds of scientists have signed it. This is mainstream, it is recent, and it is not a fringe position. Notice the careful phrase at the center of it: realistic possibility. Not proof. Not consensus that insects are conscious. The declaration is not a claim about what is true. It is a claim about how to act when you do not know, which is a different and more defensible kind of statement, and it is why the document has held up. The hardest cases in it are the ones furthest from us. An octopus has roughly 500 million neurons, which puts it in the same range as a dog. But about 2/3 of them are distributed through the arms rather than centralized in a brain, and each arm can solve problems semi-independently. Whatever it is like to be an octopus, there may not be a single answer, and there may not be a single subject to have one. That is not mysticism. It is an anatomical fact with no comfortable interpretation. One correction, and it costs a sentence, but it buys this entry its credibility. Trees do not have experiences. Plants have genuinely sophisticated signaling, chemical, electrical, between individuals through fungal networks, and none of it constitutes awareness. A group of plant scientists published a direct rebuttal to the plant consciousness literature, arguing that plants neither possess nor require consciousness, and they are right. There is no nervous system, no centralization, and no evolutionary reason for one in an organism that does not move. Include the correction. The scenario does not need it, and it is not true. So here is the scenario, and it must be labeled clearly, because it is the most speculative entry on this list so far. The proposal is contact by direct transfer of experience rather than by language, and the transfer arriving without the filters that evolution installed. Not a message about what it is like to be someone else, but the thing itself, delivered whole. There is no known mechanism for this. Nothing in neuroscience describes a route by which one nervous system could be handed the contents of another, let alone the accumulated contents of a biosphere. Every other entry on this list has been anchored to something built or measured. This one is anchored only to a limit. It is worth saying why the mechanism is not merely undiscovered, but hard to even specify. Experience, as far as anyone can tell, is not a file. It is not stored anywhere that could be read off and transmitted. What a brain has is a physical state, a particular configuration of 86 billion cells, their connections, their chemistry, and their timing, all of it embedded in a body with its own history. To hand that to someone else, you would have to reproduce the configuration in their hardware, which is not delivery. It is replacement. There is no version of this that resembles receiving a message. The only version that works is becoming, briefly, something else. But the limit is real, and that is why it earns its place. Human empathy has a documented ceiling, and the ceiling is not a moral failure. It is a design feature, without which nobody could function. The reason a person can eat lunch while knowing what happened in the building the lunch came from is not hypocrisy. It is that empathic response falls off sharply with distance, social, physical, temporal, in a graded and measurable way. You feel a great deal for one person in front of you, and much less for 1,000 people described in a report, and that gradient is not a defect in your character. It is a mechanism, and it is load-bearing, and it is running right now. There is a measured version of that gradient that is worth stating precisely because it is one of the more uncomfortable results in psychology. Present people with one identified individual in difficulty, and they respond strongly, with attention, with money, with concern. Present them with two, and the response does not double. Present them with thousands, and it falls. The curve is not flat and rising slowly. It bends downward. Researchers call this psychophysical numbing, and the practical version of it is that the more people are suffering, the less any individual is moved. That is a finding about arithmetic, not about morality. Our capacity to feel is calibrated to a group small enough to know, because that is the group our ancestors lived in, and the calibration did not update when the numbers did. The scenario simply asks what a species is if you remove it. And here is the line this entry exists for. There is no version of this scenario in which the aliens do anything cruel. Nothing arrives with hostile intent. What arrives is understanding, complete, accurate, undistorted understanding of what everything else is experiencing. The damage is done entirely by the accuracy. That is a genuinely unusual shape for a catastrophe. Every other entry on this list has a villain, or a machine, or an indifferent process. This one has a gift, delivered by someone who meant well, and the harm is a property of the truth rather than of the giver. It also has an odd relationship with the entry 3 places above it. The merciful extinction scenario imagined a civilization that concluded suffering should be ended and had the means to end it. This one imagines a civilization that concluded suffering should be understood and had the means to transmit it. Both are acts of moral seriousness. Both are performed with care. And the reason they belong on this list is not that either is malicious, but that a sufficiently capable species acting on a sufficiently confident ethical conclusion is a category of danger that has no defense, because there is nothing to negotiate with. You cannot deter someone who is helping. So why number 3? Because of a structural feature that separates it from everything above it. In every entry higher on this list, the notice and the event are separate things. You could, in principle, be told. Someone could send a warning, and the warning would be information about something that had not happened to you yet. That is what a warning is. Here they are the same object. The information is the event. To be warned about this in any detail sufficient to prepare for it would be to undergo it, because the content of the warning is the experience itself. A partial version is a partial dose. A complete briefing is the thing. There is no defensive posture available, no distance you can stand at, no instrument that can be pointed at it from outside. Every other scenario permits an observer. This one does not, because the observer is what it operates on. It is the first entry on this list where the boundary being crossed is the boundary of the self. And the uncomfortable part is that it does not require anything to arrive at all. Everything in this entry that has actually been measured, the ceiling, the cost, the burnout, the gradient with distance, the 80 billion, is already true tonight. The scenario does not add a single fact to the world. It only removes one limit. And we live inside that limit continuously, every day, without ever noticing that it is holding something up. The last 2 entries on this list are the only ones where the mechanism is already in place, already measured, and already running. The next one has been running since 1974. Number 2, the ones who kept us quiet. The scenario at number 2 is that the silence is not an absence, and not a policy, but protection. That something in this galaxy removes civilizations once they become detectable, and that the quiet we hear is the quiet of a place where being loud is fatal, and that if anyone has been shielding us, the shielding has now failed, because our signals have already gone out. Here is the framing that makes this entry work, and it should be stated up front. The predator is the speculative part. Everything else in this entry has been measured. How detectable we actually are, who is in a position to see us, when they became able to, and what we have deliberately sent, none of that is hypothesis. It has been calculated from catalogs, and the numbers are specific. Start with how you find a planet. The most productive method by far is to catch it crossing in front of its star, which produces a small, regular dip in brightness. That is how Kepler found thousands of them. But it only works from a particular vantage point. You have to be positioned close to the plane of the planet's orbit, so that the planet passes between you and the star. From anywhere else, the planet goes above or below, and you see nothing at all. The narrow band of positions from which a transit is visible is called the transit zone. Now turn the question around, which is the move that makes this entry. Do not ask which planets we can see. Ask which stars are positioned to see Earth cross the face of the Sun. That question has an answer, because it is a geometry problem with a catalogue attached. In 2021, an analysis combined the Gaia catalogue of stellar positions with stellar motions, because the set of stars in the right position changes over time as everything moves, and produced a specific list. 1,715 stars within about 300 light-years have been in a position to see Earth transit the Sun at some point during the last 5,000 years. A further 319 will move into that position over the next 5,000. Of those, roughly 75 are within 100 light-years. And a subset, on the order of 2 or 3 dozen, are close enough that our own radio leakage, expanding outward since the 1930s, has already reached them. Several of the stars on that list are already known to have planets. That is the fact this entry is built on, and it should be delivered plainly, because it is easy to miss how unusual it is. We do not have to speculate about whether anyone could have noticed us. We have a list. It has names on it, and distances, and dates. It says precisely which stars have had a view of this planet crossing its star, showing an atmosphere with oxygen and methane in it, which is a combination that is difficult to sustain without biology. What we do not have is any reason whatsoever to think anyone is at any of them. That is the whole situation in 2 sentences. The detectability question is settled. The occupancy question is completely open. It is worth being honest about how difficult the observation actually is, because the difficulty tells you something about who could be doing it. The Earth, crossing the face of the Sun as seen from another star, blocks about 0.08% of its light. Not 8%. 0.08%. To detect that, you need to measure the brightness of a star to a precision of about 1 part in 12,000, repeatedly, and then wait a year to see whether it happens again, and then wait another year to be sure. And to learn anything about the atmosphere, you have to do considerably better than that. You have to separate out the fraction of starlight that passed through a shell of air a few tens of kilometers thick on its way past. We can just about do this. It has taken us space telescopes to manage it, and the atmospheric part is at the very edge of what our best current instrument can achieve, for planets much larger than Earth, around stars much smaller than the Sun, which sets the bar for the scenario. Anyone monitoring this planet from 100 light-years away is not doing something trivial. They are doing something we have only just learned to do at all, at greater range, and presumably continuously. That is not evidence that nobody is doing it. But it does mean the scenario requires an observer at least as capable as we are, which is a stronger requirement than it usually gets credit for. There is a second thing worth knowing about that list, which is that it is not fixed. Stars move. The set of them that can see Earth transit is a slowly changing population. Some drift into the zone, some drift out, on timescales of thousands of years. Which means the question is not only who can see us, but who could have seen us, and for how long, and whether their window overlapped with the interval in which there was anything here worth noticing. A star that had a clear view of this planet 400 million years ago saw a world with life on it, and nothing else. The window that matters is very much narrower than the window that exists. Now, leakage is accidental. It spreads in all directions, thins with the square of the distance, and beyond a few tens of light years, picking it out would require an instrument larger than anything we have built. It is worth dwelling on that for a moment, because the image of an expanding sphere of our broadcasts, announcing us to the galaxy, is misleading in a specific way. The sphere is real. But the signal within it is being diluted continuously by geometry, and it does not stop diluting. At 100 light-years, our loudest accidental transmissions are far below what a copy of our own equipment could pick out of the noise. The bubble is expanding and fading at the same time, and the fading wins. Deliberate transmission is a different matter, because it is focused rather than spilled, and there have been a handful. The most famous went out on the 16th of November, 1974, from the 1,000-foot dish at Arecibo in Puerto Rico. Frank Drake was among its authors, and so was Carl Sagan. It was aimed at the globular cluster M13, about 25,000 light-years away, and it ran for roughly 3 minutes. The message is 1,679 bits long, and that number is the cleverest thing about it. 1,679 is the product of two prime numbers, 73 and 23. Which means there is exactly one sensible way to arrange those bits into a rectangle. Anyone receiving a string of that length who thinks about it for a moment has only one option, and if they take it, a picture appears. What appears, in order down the grid, the numbers 1 to 10. The atomic numbers of the elements in DNA. The formulas for its nucleotides. The double helix itself. A human figure with our height and our population. The solar system, with the third planet lifted out of line to indicate where the sender lives. And at the bottom, the telescope that sent it, with its diameter. The dish collapsed under its own weight on the 1st of December, 2020, 51 days short of the 46th anniversary of that transmission. Other messages have followed, aimed at nearer targets. One was sent in 2017 toward a red dwarf about 12 light-years away. If anyone is there, and if they answer immediately, the earliest possible reply arrives in the early 2040s. That is a real date on a real calendar, and it is close enough that most people listening to this will be alive for it. But the most instructive thing anyone has done in this area was not a transmission outward. It was a rehearsal. In 2023, a European spacecraft in orbit around Mars transmitted an encoded message back to Earth, deliberately staged as though it were a signal from an extraterrestrial civilization. 3 radio observatories on this planet received it, exactly as they would receive a real one. The raw signal was then released publicly, and the puzzle was split into 2 halves. First, extract the message from the data, and then work out what it says. Members of the public solved the extraction within days. And the decoding, the harder half, which the professional teams had not managed, was solved by a father and daughter working on it together at home. The content turned out to be a depiction of amino acids. That is the closest thing to a first contact rehearsal anyone has ever run, and what it demonstrated was not the quality of our instruments. The instruments were never in doubt. What it demonstrated is that the hard part of contact is interpretation, and that interpretation can be done by people with no institutional standing at all, working from a public data release in their own time. Which brings us to the part of this scenario that is usually its climax, something detected moving in our direction. And the real version is better than the story. We have now confirmed 3 objects passing through this solar system from interstellar space. The first was found on the 19th of October 2017 and named Oumuamua, a Hawaiian word meaning, roughly, a scout or messenger from the distant past. It was strange in several ways at once. Its brightness varied so dramatically as it tumbled that its shape had to be extremely elongated. It showed no visible tail, so it did not appear to be a comet. And it accelerated slightly as it left, by an amount gravity alone does not account for. That combination produced years of argument, including a prominent claim that it might be artificial, a claim the field examined and did not accept, and which most of the people who work on small bodies regard as considerably weaker than the natural explanations. The second, found in 2019 and named for the amateur astronomer who spotted it with a telescope he had built himself, behaved like an entirely ordinary comet. It had a tail. It had the expected chemistry. It was, in every respect, unremarkable, and by being unremarkable, it made the first one stranger, because it demonstrated that interstellar visitors do not have to be puzzling. The third was discovered on the 1st of July 2025, on a strongly hyperbolic path, with a velocity indicating that it came from the older population of stars in this galaxy, which makes it, plausibly, a great deal older than the Sun. The honest framing here matters. None of these is a spacecraft. There is no evidence that any of them is anything other than a rock or a comet, and the burden on anyone claiming otherwise has not been met. What they establish is different, and for this entry, more useful. The traffic is real. Material from other star systems moves through this one routinely, and it always has. Until 2017, we had never caught a single piece of it, not because it was not there, but because we did not have survey telescopes fast enough to notice something moving that quickly on a path that does not come back. In 8 years, we found 3. That number is a statement about our instruments, not about the galaxy. And the rate is expected to rise sharply as wider and faster surveys come online, which means the interesting question is no longer whether we will find more. It is how strange the strangest one turns out to be. So why does this scenario sit at number 2? Because the deadline, in the scenario's own terms, has already passed, and it cannot be recalled. Radio travels at the speed of light and does not come back. Our earliest transmissions of any real power date to the 1930s, which puts the leading edge of the leakage bubble roughly 90 light-years out and expanding by 1 light-year every year. The Arecibo message is 52 light-years out. Every argument anyone has about whether transmitting was wise is an argument about something that has already happened, conducted entirely after the fact. And here is the part that is easy to miss. The scientific community did have this argument, seriously, and it did not resolve it. In 2015, a statement was published and signed by a substantial group of scientists and technologists, arguing that deliberate transmission to other stars should not proceed without a worldwide scientific, political, and humanitarian discussion first. Their reasoning was not that transmitting is dangerous. It was that we have no way whatsoever to estimate the risk, that the probability of a bad outcome is not small, it is unknown, and that unknown is a different category from small. This was not a fringe document, and the people who signed it were not cranks. It also has no enforcement mechanism of any kind, and there is no plausible way to build one. The capability sits with anyone who owns a sufficiently large dish and decides to use it. And the counter-argument to the whole worry is worth giving, because it is strong, and it is the reason the scientific mainstream is not especially alarmed. A civilization capable of crossing interstellar distances to do anything to us is, by definition, capable of detecting an inhabited planet without waiting for it to send a greeting. Oxygen in an atmosphere is a far louder signal than anything we have deliberately transmitted. It has been broadcasting continuously for well over 2 billion years, and it cannot be switched off. On that reading, deliberate messages add essentially nothing to a signature the planet has been emitting since long before anything on it could think. The reply to the counter-argument is that oxygen tells you there is life, and a radio transmission tells you there is someone building transmitters, and those are extremely different pieces of information. Both points are correct. Neither settles it. The argument remains open, which is precisely the condition it was in when the statement was drafted. That is the real content of this entry, once the predator is set aside. Whatever anyone concludes about whether announcing ourselves was wise, the announcement has been made. It was made by us, in several installments, by a small number of people who did not consult anybody, and it is now 52 light-years past the point where any consultation could matter. Which leaves one entry, and the reason it is first has nothing to do with how likely it is. It is first because it is the only scenario on this list that could not be detected even in principle, and the physics that makes that true has already been demonstrated on a laboratory bench more than once. Number 1. The editors. We have arrived at the entry that is first on this list and least likely to be true, and the reason those two things are compatible is the whole point of the countdown. Start in 1935, with 3 physicists and an objection. Albert Einstein, Boris Podolsky, and Nathan Rosen published a paper with a title in the form of a question: can quantum mechanical description of physical reality be considered complete? Their answer was no. Their reasoning was careful. Quantum mechanics predicts that if you prepare 2 particles together in a certain way and then separate them, measuring a property of one instantly fixes the corresponding property of the other, no matter how far apart they have traveled. Einstein found this intolerable. He called it spooky action at a distance, and he drew what seemed the obvious conclusion. The particles must have carried their properties with them all along, decided at the moment they parted, and quantum mechanics simply fails to describe those hidden details. It is a reasonable position. It is the position most people arrive at on their own when the situation is explained to them. 2 gloves in 2 boxes, sent to opposite sides of the world. Open one and find it is left-handed, and you know instantly that the other is right-handed. Nothing traveled. The answer was packed at the start. For 29 years, that was where the argument sat, because there seemed to be no way to test it. It looked like a matter of taste. Then, in 1964, John Stuart Bell showed that it was not. Bell derived an inequality, a limit on how strongly the results of measurements on 2 separated particles can be correlated, if the particles carried their answers with them from the start. It is a statement about statistics, and it holds for any theory of that kind, whatever the hidden details turn out to be. And he showed that quantum mechanics predicts correlations that exceed it. That turned a philosophical dispute into an experiment. Prepare many pairs, measure them in varying combinations, count. If the correlations stay under the limit, Einstein was right. If they exceed it, the gloves were not packed. There is a detail about that paper worth keeping, because it says something about how this subject has always been treated. Bell published the most consequential theoretical result in the foundations of quantum mechanics, in a journal so obscure that it folded after 4 issues. He was working at a particle physics laboratory at the time, and this was not his job. It was what he did on leave. The paper was largely ignored for the better part of a decade. The experiments began in the 1970s and have been refined continuously ever since, closing one loophole after another. Each loophole was a way the result could have been faked by ordinary physics, and each one had to be shut separately. Were the 2 detectors far enough apart that no signal could have passed between them during the measurement? Were enough of the particles actually detected, or could the undetected ones have been hiding a conventional explanation? Were the settings chosen freely, or could they have been influenced by something in the particles' shared past? By 2015, experiments had closed the major ones simultaneously, in the same run. The results have gone one way, every time, in every laboratory, for 50 years. The correlations exceed Bell's limit. In 2022, the Nobel Prize in Physics was awarded to Alan Aspect, John Clauser, and Anton Zeilinger for that work. local hidden variables are excluded. Whatever is happening, the particles did not carry the answer with them. That is the established background. Now comes the part this entry is actually about. In 1978, John Archibald Wheeler proposed a variation with a structure that is difficult to sit with, and it has since been performed. Take an apparatus that can be configured in one of two ways. In one configuration, it reveals which of two paths a particle took. It treats the particle as a particle, and you get an answer to the question which way. In the other configuration, it reveals an interference pattern, which requires the particle to have traveled both paths, and treats it as a wave. Standard quantum mechanics is comfortable with either. What Wheeler proposed was to choose the configuration after the particle has already passed the point where, on any classical account, it must have committed to one behavior or the other. The classical expectation is clear. The particle did something. Whatever it did is now in the past. A choice made afterwards can only reveal what already happened. It cannot reach back and alter it. The experiment has been done, in more than one form. In 2007, a group in France performed the single photon version. A photon entered the apparatus, and while it was in flight, after the point of no return, a quantum random number generator selected the configuration. The generator was built to make the choice as unpredictable as physics allows, so that nothing could have anticipated it. In 2015, a group in Australia did it with a helium atom instead of a photon. That matters more than it sounds. An atom has mass. It has internal structure. It is not a wisp of light. If the result held for photons only, it could be dismissed as a quirk of how light works. It held for the atom. And the result, stated as carefully as it deserves, is this. The outcomes always match whichever configuration was eventually chosen. Choose the which path setting late, and the data show particle behavior all the way through. Choose the interference setting late, and the data show wave behavior all the way through. There is no residue, no partial commitment, no trace in the record of the particle having decided anything before the choice was made. Wheeler pointed out that the same experiment is available at astronomical scale. Light from a distant object, bent around an intervening galaxy by gravity, travels two paths for billions of years before arriving here. How we choose to combine that light, tonight, determines which description applies to a journey that finished before the Earth existed. And something close to that has been done. In 2018, an experiment used light from two distant quasars, one of them emitted billions of years ago, as the source of the settings in a Bell test. Consider what that apparatus actually is, because it is one of the stranger objects human beings have built. Two telescopes on a mountain, each pointed at a different quasar. The light entering one of those apertures tonight left its source before the sun existed, and has been traveling ever since through intergalactic space, and is arriving now for the first and only time. That light is not the subject of the experiment. It is the experiment's dice. The color of an individual photon, determined billions of years ago in a galaxy nobody has named, is measured on arrival and used to decide, within the last microseconds, which of two measurements to perform on a pair of entangled particles in a laboratory below. The whole design exists to make one thing impossible. The setting cannot have been arranged in advance by anything local, because the thing that set it has been in flight since before there was a solar system to arrange anything in. The idea was to eliminate the last hiding place for Einstein's position, the possibility that the choice of measurement was somehow correlated with the particles beforehand. By taking the settings from light that old, any such conspiracy would have to have been set up that long ago. The correlations held. Whatever the answer is, it was not fixed in advance, and the earliest moment at which it could conceivably have been arranged has now been pushed back past the age of the Earth. Now comes the correction that makes this entry honest, and it is the most important sentence in this video. These experiments do not show that a choice made now changes the past. They do not permit sending a signal backwards. This is not an open question, and it is not a matter of which interpretation you prefer. It is a theorem, and it follows from the mathematics of the theory itself. Quantum correlations, however strange they are, can never be used to transmit information, not faster than light, and not backwards in time. Every physicist working in this field agrees on this. If you look at the results from one side alone, without comparing them to the other, they are indistinguishable from random noise. The strangeness only appears when the two records are brought together afterwards, and bringing them together requires an ordinary message, traveling forwards, at or below the speed of light. This is also why the delayed choice quantum eraser, which is the version of this experiment that circulates most widely, is misreported almost every time it is described. Nothing is erased from the past. The correlations are always there in the full dataset. What changes is which subset you are able to sort the data into, and you can only do the sorting once you have both halves in hand. So what do these experiments actually show? They show that the assumption of a definite prior history is not merely unproven. It is inconsistent with the data. There is no fact of the matter about which path the particle took until there is a measurement. The past, at this level, is not a completed record sitting in a vault waiting to be consulted. It is an account that gets settled when it is asked about, and not before. Wheeler's own summary was that no elementary phenomenon is a phenomenon until it is a registered phenomenon. That is not mysticism, and it is not a metaphor. It is the conclusion of a century of increasingly careful experiments, arrived at against the stated expectations of the man who wrote the paper that started the argument. Einstein believed the universe would turn out to be less strange than it looked. He was wrong, and he was wrong in a way that has now been measured to extraordinary precision. And then the harder half, which has to be delivered alongside it, because without it, the first half becomes a license to say anything. None of it can be used. The past may be genuinely open at the level of the very small, and you can never, by any means, at any level of technology, reach it. There is no lever. The no-signaling theorem is absolute, and it is absolute in the same way that the conservation of energy is absolute, not as a practical difficulty, but as a structural feature of the theory. A universe stranger than Einstein was willing to accept, and no more negotiable than the one he expected. So here is the scenario, and it is clearly labeled as a scenario, because at this point on the list, that labeling is the only honest thing left. Suppose a civilization could operate on that structure, not traveling through a history, selecting among them, not editing a timeline in the sense of altering a record, but choosing which of the possible accounts becomes the one that was the case. Hugh Everett's 1957 interpretation supplies the picture the scenario borrows. Everett proposed that quantum outcomes do not resolve into one result at all, that every outcome occurs in branches that thereafter do not interact. It is a serious interpretation, held by serious physicists. Everett's own story is a small, sad footnote that belongs here. He published the work as a doctoral student. It was received badly by the senior figures of the field, and he left academic physics almost immediately afterwards for a career in defense analysis. He never published on the subject again. The interpretation was largely ignored for a decade before others revived it, and he did not live to see it become respectable. It should also be said plainly that Everett's own theory contains no editors, no selection, and nobody choosing anything. Branches do not get pruned in it. Nothing is discarded. And it is one of several interpretations, none of which has ever been experimentally distinguished from the others. They all make the same predictions for every experiment anyone has been able to devise, which is precisely why the argument between them has lasted 70 years and shows no sign of ending. Choosing between them today is a matter of taste, and the honest practitioners say so. There is one more result worth mentioning, because it is real and it is genuinely disorienting. The line of work known as Wigner's friend, developed theoretically in 2018 and probed with photons in 2019, establishes that under a small set of reasonable assumptions, two observers can each apply quantum mechanics correctly and arrive at incompatible conclusions about what happened. Not different opinions. Different facts, both derived properly. Reality, it turns out, is not obliged to supply a single shared account of an event. And now, the ranking axis pays off, which is what this entire list has been building toward. Every entry has been ranked by one question: how late does the warning arrive? At number 10, the warning arrives whenever they decide it should. The watchers are in control of the timing, and there is nothing about that scenario that prevents them from making themselves known tomorrow. At number 9, the warning arrives with the machinery. You would see the infrared. You would see the transit. There would be time, and it would not help, but there would be time. At number 8, the warning arrives with the event itself, traveling at the speed of light, which is the earliest arrival that physics permits, and is still too late by exactly the amount that matters. At number 7, the warning never arrives, because there is no event. There is only a gradual absence somewhere else, long ago. At number 6, the warning is 4 billion years late, and it is written in the only document we cannot read from outside. At number 5, the warning arrives, in full, in detail, and changes nothing, because self-consistency does not permit it to. At number 4, the warning is the trigger, and beneath that, the deeper problem. Every instrument that could deliver it is part of the thing it would be reporting on. At number 3, the warning is the event. There is no version of being told that is not the thing itself. At number 2, the deadline has already passed. It passed decades ago, at the speed of light, and no decision made now can overtake it. And at number 1, there is no warning, ever, in any possible universe. Not because we lack the instruments, and not because it is too fast or too far. Because a warning is a record, and on this scenario the record is the thing being selected. Any evidence would be part of what gets chosen. The scenario's own logic guarantees that a universe in which it is happening is indistinguishable, in every detail, from one in which it is not. It was never repeated. That phrase belonged to the wow signal, 49 years ago now, and to the 45 years of instruments pointed back at that patch of Sagittarius by men who never saw it again. On this scenario, that is what every discarded history looks like from inside the one that survived. Not a mystery. The residue of a version that stopped being the case. And that is not a claim. It is the shape the scenario would take, and it is precisely as untestable as it sounds. It explains the wow signal, and it explains a signal that never happened, and it explains its own absence, and a thing that explains everything explains nothing at all. A hypothesis that seals itself. That phrase came from number 10, from John Ball's own honest admission about his own idea, that a perfectly executed policy of silence would be undetectable in principle, and that this was the weakness of what he was proposing. He said it himself, in the paper, in 1973. At number 1, that property stops being the flaw in one entry and becomes the destination of the entire descent. 10 scenarios, each one less detectable than the last, ending at one that cannot be detected at all. Not by us, not by anyone, not ever. Which brings us to what has to be said about this list, and it should be said plainly, because it is the reason the list was ordered this way. Unfalsifiable is not a compliment. Number 1 is at the top, not because it is the greatest danger, and not because it is the most likely. It is the least likely thing here, by a considerable margin. It is at the top because of a structural property, because it is where evidence runs out, and there is nowhere further to go. And look at what happened to everything above it. The WOW signal was reobserved for 45 years by 2 men who bought their own equipment and talked their way onto the best instruments in the world and reported honestly that they found nothing. Tabby's star was measured in every color available until the answer came out. It dims more in blue than in infrared, so it is dust, and it cannot be a solid object. 7 Dyson Sphere candidates were flagged, and 17 days later, a different team checked all 7 against 4 radio surveys and found galaxies hiding behind them. The stability of the vacuum was traced to 2 particle masses, and both were measured to a fraction of a percent. Somebody built a machine in Illinois out of aluminium and laser light to ask whether space itself is pixelated, ran it, and wrote up the null result. Every scenario on this list that made a prediction was tested. Every one of those tests came back with a real answer, and in most cases, the real answer was no. That is what this subject looks like when it is working. It is not people staring at the sky and wondering. It is people building instruments to check specific claims and reporting what the instruments say, and being willing to have spent 4 decades on a question that turned out to have a boring answer. Number 1 is what is left when there is nothing to point an instrument at. So we end where we began, with the numbers from the top of this list. 93 billion light-years across. 2 trillion galaxies. 10 billion candidate worlds in this galaxy alone, and by extension, something beyond ordinary counting across all the rest. And a confirmed detection count, after 75 years of looking, of 0. The real subject of this list was never the aliens. It was the shape of an edge. The boundary between what can be checked and what cannot, and how quickly the second category swallows the first once you stop asking for evidence and start asking only whether a story could be true. Because every scenario here could be true. Not one of them has been ruled out by physics. What separates the top of this list from the bottom is not danger, and it is not plausibility. It is testability, how much of each scenario touches the world in a way that could ever come back to us as a number. The distance from number 10 to number 1 is the distance between science and a story. Both are worth having. Only one of them can be wrong, and being able to be wrong turns out to be the more valuable property. The sky above you tonight is the same sky Fermi looked at in 1950 and Eamon recorded in 1977, and every instrument in this list has been pointed at since. It has not answered yet, but it has been asked, carefully, by people who wrote down what they found, even when what they found was nothing at all. And that is a quieter kind of company than the one this list has been describing, and a considerably more reliable one. Let that hold you for a while. Sleep well, and good night.